He opened on silence. Not the silence of a room after a door closes, but the older quiet of space where sound has never traveled, where only light knows the way. There, a polished flower of beryllium faced the cold and met the past. Its gold hexagons gathered a rain of photons that had wandered for almost the entire age of everything. Their color faded by time, until the universe itself had turned them to infrared. The mirror did not blink. It steadied its gaze beyond the familiar swarms of modern galaxies and listened for the earliest syllables of creation. In that listening, a drama took shape. Light that began when hydrogen was young arrived as a trembling whisper against detectors colder than the shadows around them. The whisper resolved into patterns, specks arranged with an intention that no eye had seen before. Each speck was a city of suns, scaled down by distance, stretched by expansion, yet stubbornly bright. The telescope gathered them one by one, patient, almost contemplative, as if counting beads on a rosary of time. What appeared was not emptiness, but an unexpected crowd, a cosmological sunrise already busy with structure. He did not judge, only recorded. Mirrors cannot be surprised, but the minds that built them can be. Expectations had been trained on a gentler dawn, a slow awakening in which the first stars kindled warily, and the first galaxies required long ages to assemble. The images contradicted that gentle script. Compact beacons flared where a thinner fog had been presumed. They were small by the standards of the nearby universe, yet their signals carried urgency, as if formation had been a sprint rather than a crawl. The idea of a quiet morning gave way to the sense of a brisk, purposeful daybreak. Around those distant beacons, darkness remained, but it was a different darkness now. It had context, a canvas charged by the simple fact that luminous matter had already organized itself. The telescope traced their colors through narrow windows in the infrared, intervals where the atmosphere of Earth would once have interfered, where earlier instruments had lacked the reach or the clarity. Here, in the chill and steadiness of its vantage point, the new eye separated starlight from shadow with a precision that felt intimate. It was not just seeing objects, it was sampling the grammar of the early cosmos. The grammar held rules. Blue shifted toward red through space that swelled like a tide. Spectral breaks where intergalactic hydrogen gulped photons. Faint emission lines that hinted at metal made in furious furnaces. The mirror, the instruments, the engineering that kept them all in a delicate thermal balance, gave those rules sentences to live in. And within those sentences, contradiction lived too. If matter required time to condense, if gravity needed patience to sculpt, then why did the distant light already carry the sheen of experience? Why did the first cosmic pages look annotated? The eye of the telescope did not offer conclusions. It offered presence. It gave the universe a way to reveal itself, without the distortion of proximity or the blur of atmosphere. It allowed a human artifact to inhabit a Lagrange point where the push and pull of Earth and Sun cancelled into a plateau of calm. In that steadiness, the instrument could become a vessel for light, older than any world where minds wander. Gold met darkness. Darkness yielded detail. This exchange felt ceremonial, the way a curtain slides in a dim theatre and the stage is not empty after all. Across those early frames, the colour of distance took on personality. Red was no longer only an adjective for heat or warning. It was a measure of age, a ruler laid along the expanding fabric of reality. The reddest pinpricks were also the youngest in cosmic chronology, yet they looked practiced, industrious, sure of their roles. Some appeared like knots pulled tight in a woven field. Some stretched, lensing and thin, distorted by the gravity of closer masses. Even these distortions served the vision. They acted as magnifying glasses arranged by chance, revealing sharper outlines and deeper contrasts. Nature collaborated with the instrument, one lens layered on another. No human voice traveled with those photons. The stories they carried were encoded in absence and slope, in ratios of brightness across filters, in the spaces where the spectrum fell off abruptly. In that sparse language, a sense of urgency took root. Something about the way light pooled in small volumes and the way colors traced energetic young stars suggested haste, not chaos, but eagerness. If the universe had a personality at that hour, it was decisive. Chemistry began early. Gravity moved quickly. Radiation pressed outward, while matter clumped, a conversation of forces that wrote itself faster than anticipated. The night that received these images was patient as well. Screens glowed in quiet rooms. Teams leaned in, not to cheer, not to mourn, but to witness. Their craft had unfolded in the cold without a hand to guide it. Their calculations had met the strict indifference of physics and passed. And now the reward was neither a single headline nor a simple answer. It was a field, crowded with beginnings. The weight of that crowd felt beautiful, a relief from the old worry that the first billion years were only murk and delay. Beauty, here, was not decoration. It was information, light arranged in forms that signaled processes at work. At the heart of the mirror, the pattern of hexagons did more than shine. It allowed exquisite control. Segments adjusted by fractions of a wavelength made the difference between a blurred smudge and a crisp point. That crispness transformed the question of what is there into the richer question of what has already happened. Photons that left their birthplaces before any planet had cooled were now receipts of events. They testified to explosions that minted elements, to accretion that fed central potentials, to wines that shaped a medium. The telescope read those receipts with a calm that felt like respect. Beyond technique, there was the sensation of looking at time itself. Each red point was not simply far, it was earlier. The mind held that double meaning as a single experience. Distance and age merged into a tender intimacy with origins. The instrument, far from the chatter of weather and the heat of earth, turned this abstract merger into a visual encounter. To behold those points was to accept a lesson in humility and in kinship. All that followed, all the clusters and spirals and finally the little blue world of water and carbon, would grow from similar knots of light. The seed was evident. The garden had started. Silence continued to accompany the images, but it lost its emptiness. It became the hush before a revelation, the pause artists use to enlarge the moment when a shape emerges from the canvas. In that hush, the first impression hardened into a truth that could not be ignored. The cosmic dawn was not thin. It was populated. It was busy. It had texture. The telescope had not caught a fragile flicker clinging to existence. It had observed a confident generation of structures already engaged in the work of shining, forming, transforming. The surprise was not loud. It was precise. In the realm of feeling, this precision carried weight. The mirror was a tool, yet the encounter resembled a pilgrimage. A device built from equations and alloys became a witness to the first lights that would one day allow eyes to exist. There is a strange tenderness in that loop. The early universe poured energy into luminous knots. Those knots seeded the chemistry for worlds. On one such world, creatures calculated how to send a gold mirror into darkness to meet the light that had made them possible. In that meeting, a long circle closed, and a new curiosity opened. He kept watching. Photons arrived in more patient streams, more fields, more angles. The rhythm held steady, unhurried, tireless. Patterns coalesced. The sky of the ancient past grew familiar, then complicated, then intimate. Every point that sharpened into a profile enriched the feeling that the universe, when young, moved with a conviction that had been underestimated. Certainty did not come from an appeal to authority or tradition. It came from light finally delivered and faithfully measured. In that faithful measurement, the earliest chapter of reality began to speak in a voice that sounded both foreign and homelike. It sounded like a beginning that had never ended, only continued to unfold, now witnessed with a clarity worthy of its first fire. He faced a sky so old that light itself seemed tired. In that cool abyss, a blossom of gold petals waited, poised in a darkness that had never known a sunrise. The mirror opened its eye and steadied its breathing of heat and cold until the metal grew as quiet as frost. There, in the calm near a balance point between Earth and Sun, the instrument became something more than engineering. It became a listener. Photons, older than every mountain and ocean, arrived as faint threads, stretched thin by expansion, reddened into whispers the human body could never sense unaided. The mirror gathered them with devotion and delivered them to detectors that had been lulled into a near-perfect stillness. The numbers began to appear. They did not shout. They arranged themselves as if memory had found a way to glow. He did not hurry. Patience was built into every hinge and every stitch of thermal shielding. In that patience, the first frames resolved from noise into intention. What looked at first like a scattering of dust became islands of light. Each island contained the labor of gravity working on cold gas, the quick spark of stars born in tight knots, and the soft shrouds of dust that already suggested violence and repair. The mind that watched the data felt a slow tilt, as if the universe had leaned closer to be understood. The expectation of emptiness dissolved. The earliest canvases were crowded. That crowding did not read as clutter. It read as industry. He traced color across a ladder of infrared filters and found a pattern that only distance could produce. Where visible light would have blazed, there was absence. Where the eye of the mirror lived, in the long waves, there was presence. The gap itself was a message, the signature of hydrogen between the galaxies stepping in to swallow the bluest photons. That absence carved a clean edge in the spectrum, a cliff that said the source lived on a far shore of time. The signals were small but deliberate. They were not scraps. They were sentences cut short by the fog of a young cosmos that had not yet learned to let light pass freely. He listened harder, and the sentences grew longer. Emission lines rose like delicate wires over the continuum, hints of oxygen and neon born in stars that had fused their cores hot and fast. The shape of those lines suggested not a gentle campfire but a forge. It suggested populations of stars more massive and short-lived than the familiar, stars that lived like sparks in a gust. Their deaths would have been both gift and destruction, scattering elements into the gas and driving winds that carved negative space where new stars could gather. The mirror could not watch those lives unfold in real time. It could only receive the fossilized glow of their aftermath. Yet even that glow carried urgency. He read the urgency in compactness. Some points were so small that even the sharpness of the gold segments could not tease them wider. Their brightness, measured against their size, implied that their contents were dense and busy. In other cases, the points stretched and arced, warped by the gravity of clusters between the observer and the source. Nature had placed magnifying glass after magnifying glass into the path, and the instrument respected the gift. It measured the elongated arcs and, in their distortions, found clarity that would otherwise have taken decades of exposure to earn. Distant knots resolved into substructures. The oldest morning was not only populated, it had neighborhoods. He stayed with one field and then another, allowing the noise to diminish until the sky became articulate. With deeper exposures, the number of red pinpricks grew, then grew again, like stars coming out at twilight but in reverse time. The faintest among them edged against the limits of detection, hints that teased the possibility of seeing into epochs where neutral hydrogen still ruled and starlight struggled to carve tunnels through the mist. The mind felt the old analogy return, the sense that the universe was a book and the pages were finally lighting from the corner inward. Yet the metaphor was too gentle for what the data implied. This was not a slow leafing through. It was a revelation that arrived as a crowd scene. He considered the tool itself, because understanding the vision required honoring the method. The mirror segments did not guess their alignment. They measured and moved by fractions of a wavelength until they behaved as one surface. The instruments did not endure the cold. They became part of it, sinking to temperatures where thermal noise quieted enough to let ancient light define the conversation. The observatory did not fight the pull of the sun or the earth. It found a place where their pulls balanced into a smooth glide. That grace did not diminish the achievement. It deepened it. The way the device lived in space made the poetry possible. He watched the first release of images occupy screens around the world. Some viewers saw color and form, and that was enough. Others read the metadata and felt their stomachs fall through the floor. There were redshifts that belonged to ages, barely a few 100 million years after the first expansion cooled. There were shapes that suggested complex star formation histories had already begun. There were points so bright that they implied either a ferocity in forming stars or hungry hearts at the centers, black holes learning to feed while the sky was still clearing. The shock did not arise from drama alone. It arose from the way these signals moved the goalposts of possibility. He considered distance as a biography. Each photon had traversed a space that had stretched under it while it moved, a sea whose waves grew larger as the swimmer continued. What arrived at the mirror had been weakened by that stretch, but not silenced. The persistence of those small messengers felt intimate. It was as if the universe wanted to be remembered and had found a way to mail letters that could never be lost, only delayed. The mirror opened those letters and found not confession or apology, but confidence. The early cosmos wrote with a steady hand. He let his eyes rest on one especially red smudge, whose color suggested a time when heavy elements were scarce. Even there, subtle features in the spectrum betrayed enrichment. There had already been fires, already been endings, already been the ash from which planets would one day be made. The timeline of alchemy shortened before his eyes. He felt a tightening in the chest that had nothing to do with surprise and everything to do with gratitude. The past did not withhold itself. It came forward with generosity, carrying the evidence of its own haste and discipline. He noticed how the dark between the points changed character once the points were understood. The void was no longer a synonym for nothing. It became stage and solvent and archive. It held the memory of ionization yet to come, of bubbles of transparency growing and connecting like dawn around mountaintops. It held the promise of maps still to be drawn, of fluctuations in the microwave background that would one day rhyme with the distribution of these first lights, of a cosmic web that was already strung and humming. To stare into that dark was to feel the strain of threads that could not yet be seen but were already tugging on everything visible. He imagined the original heat of creation cooling to a whisper, while gravity rehearsed its patient choreography. He imagined the first clumps of gas, blind and cold, discovering how to fall together and ignite. He imagined the radiation pressure that tried to undo the gathering and the stubbornness of matter that refused to be dispersed. These were not random pictures. They were disciplined dreams guided by data. The images told him where to place the actors, and the spectra told him what lines they might have spoken. The thrill did not come from fantasy. It came from the nearness of the unknown to the measurable. He let the mirror keep watch. The exposure continued. The clock that ran the detectors marked time in a different key from the ages measured in redshift, yet both felt united by a single task. Long after the photons had left their birthplaces, they found a receiver with the patience to honor their journey. The numbers collecting in storage were small, but they were sharp. Sharp enough to draw boundaries between theories that had once overlapped. Sharp enough to force revisions that were not cosmetic but structural. Sharp enough to make the word beginning feel like an active verb rather than a noun. He breathed with the instrument and felt the cold as a virtue. The hush around the observatory was not absence. It was a listening posture. In that posture, the first lights did not arrive as decorations. They arrived as an argument. Complexity arises quickly when conditions allow it. The proof gleamed in every pinprick that refused to be dismissed as noise. The dawn of time did not hesitate. It organized. It built. It shone. The gold mirror did not interpret. It received. Yet in the purity of that receiving, a gentle verdict formed. The earliest universe was confident and creative. It had begun like a promise already half fulfilled. He began as an idea drawn on paper that smelled faintly of coffee and ambition. The plan was simple in outline and ferociously difficult in detail. Build a mirror large enough to drink the dimmest light, fold it like an origami lantern, carry it beyond the weather and the warmth of Earth, and let it bloom where gravity balances into a quiet plateau. The map pointed to a place about 1.5 million kilometers away, a saddle in the gravitational field called the second Lagrange point. There, with Earth and Sun on the same side of the sky, the darkness would be deep, the temperatures low, and the view stable. No dawn or dusk would sweep over the optics. No atmosphere would smudge the stars. In that chill, the ancient red light would finally speak clearly. He rode a column of fire from a jungle shore. A rocket lifted him from Kourou on a December morning, the air brilliant and the stakes unspoken. Aluminum, carbon fiber, beryllium, gold, and captain were gathered under a fairing that could barely contain the folded geometry. When the fairing peeled away, the observatory was a sleeping bird. Space received it with indifferent generosity. From that moment, the choreography turned exacting. He rotated, released, unlatched, and extended. A sunshield, the size of a tennis court, stretched into 5 silvered membranes, each layer a curtain that would bleed heat into space until the instruments could hide in deep cold. The tensioning lines sang through pulleys. The membranes pulled smooth. The temperature dropped like a whispered blessing. He unlocked his spine. The primary mirror opened petal by petal. 18 hexagons of beryllium surfaced and gilded to a thickness counts of atoms thin. Each segment carried motors that could push and tip and piston by distances smaller than a wavelength of light. The secondary mirror reached forward on a tripod as delicate as a dancer's balance. The hardware had only one chance to get the sequence right. It did not flinch. The ground teams watched numbers that stood for angles and currents and motor steps. The numbers behaved. There were no cries of alarm, only a steady accumulation of confirmations that mechanical wishes had become reality. He cooled. The sunshield blocked the star that warms oceans and forests. The radiators bled heat into a darkness hospitable to precision. One instrument demanded even more. The mid-infrared camera and spectrograph required temperatures near 7 Kelvin, a cold so clean that the detector's own warmth would not masquerade as a false galaxy. A cryo-cooler carried that burden, a circulatory system that moved helium through lines and exchanges until the last residual heat let go. The other eyes, sensitive to near-infrared, settled into a calmer cold, content to work in an environment foreign to any human lung but exactly right for sensing ancient fire that time had stretched. He began to learn to see. A star in the southern sky became the practice page. At first the mirror segments produced 18 separate images, scattered points like a child's constellation. The near-infrared camera assumed a second profession as a wavefront doctor. It diagnosed the offsets, prescribed minute movements of each segment, and measured the results. Iteration after iteration, the points drew together, sharpened, and fused. In the end, the mirror acted like a single surface, a disk larger than any that had flown, a calm eye capable of drawing the faintest ink from the parchment of night. He inspected his instruments. One could measure brightness through colored windows and assemble a spectrum to reveal temperature and composition. Another could slice starlight with a grating and spread it into barcodes of lines, each line a clue about atoms, ions, and motion. A device from a northern partner could hold a target steady to the milliarc second and pry open the secrets of exoplanet atmospheres with patient staring. The multipliers of possibility multiplied together. Cameras that captured fields like tapestries lived beside spectrographs that captured stories like diaries. Open cluster, distant smudge, planetary transit, comet trail, compact nucleus. All of them found a means of confession. He tested his sight on a bright star, draped in diffraction like an ornament, then ranged outward to nebulae, where hydrogen glowed and dust curled like smoke. The images were not decoration. They were demonstrations that resolution and sensitivity had reached the promised heights. Eyes were captivated, but the instruments had a different satisfaction. They recorded that the point spread function matched design, that the detectors were quiet, that thermal stability had been achieved. Numbers were poetry, in a dialect only engineers recite, and those numbers sang. With commissioning complete, work could shift from proving existence to discovering beginnings. He turned at last to the deep. A field, near a heavy cluster of galaxies, became the sample of a universe at its most revealing. Massive halos of dark matter in the cluster bent space and magnified what lay behind, turning the background into spaghetti arcs and tiny jewels. He stared for hours that added to days, while the guiding sensors kept his aim true. The data spilled into storage as a sea of counts. Reduction pipelines would later coax the patterns from the noise. For the moment, the act mattered. The photons had arrived after a journey begun, when the first chemical furnaces were only just lit, and now they met a sensor patient enough to keep their faint promises. He did not speak, so others spoke for him. They pointed to the mirror's unusual choice of metal. Beryllium stays strong and accurate at cryogenic temperatures. Gold was not vanity, but function, an excellent reflector for red wavelengths where ancient light lives. The sunshield's 5 layers were not redundancy, but a staircase of thermal radiation where each step was cooler than the last. The position in space was not isolation for its own sake, but an unbroken winter that instruments require to maintain silence against the small warmth of their own bodies. Every aesthetic grace was born from a cold purpose. The beauty was a side effect of correctness. He carried a collection of programs planned for him long before the launch. Surveys to count the earliest galaxies, campaigns to weigh the ages of the first stars, maps to chart the fog lifting from the universe as the first sources of ultraviolet photons burned tunnels through neutral hydrogen. Some observers favored gravitational lenses as natural telescopes. Others preferred blanker regions where the census would be clean. Spectroscopists drew up lists of targets to pin down with precise redshifts, replacing candidates with confirmed inhabitants of the earliest era. The calendar filled with exposures designed to turn surprise into measurement. He met the light with particular tools crafted for patience. One spectrograph used a microshutter array, thousands of tiny doors that could open to select galaxies while ignoring their neighbors. Another employed integral field units that could collect a spectrum for every point in a small postage stamp of sky, building cubes of data where two axes marked position and the third carried color. The engineering was baroque in service of simplicity. The intent was to hear what distant galaxies said without the chatter of nearby stars, to extract the murmur of beginnings from the clamor of everything in between. He balanced on the knife edge of pointing. Tiny thrusters kissed the void to counter the photon's pressure and the gravity of a moving Earth. The fine guidance sensor watched a guide star constantly, feeding corrections like a heartbeat that never falters. Stability became a means of compassion. A stable gaze meant the faintest galaxies would not smear into invisibility. It meant spectral lines would stand up straight and honest. It meant that time invested would return not blur but truth. He served a generation raised on images yet unfamiliar with seeing time. On screens across continents, colors told a story the raw data did not. False hues mapped infrared into a palette the human eye can hold. Reds and oranges stood in for wavelengths the retina cannot sense. In those translations the public found wonder, and the professionals found a universal language for results. The unlit regions were as instructive as the luminous knots. Absence became an index, the shape of the missing light, a ruler for distance and a clock for age. Through that grammar, the cosmos began to sound less like an echo and more like a voice. He proved that a patient machine could practice a vocation. He tended the first light as a caretaker tends a garden, pruning noise, watering exposure time, sheltering delicate signals under the canopy of a 5-layer shield. The harvest was not a single fruit but a season. Seeds of insight showed everywhere. Some would grow into revisions of how quickly stars assemble. Some would challenge the ease with which black holes gain weight. Some would rename the timetable of when fog lifted from space. But the task here was not to weigh those claims. The task was to honor the method that made any claim possible. A mirror, a shield, a cold set of eyes, a stable perch in the shadow of Earth and Sun, and teams willing to trade sleep for clarity. He aimed at yesterday by design and found a way to make the oldest light feel immediate. The feat is a paradox that waits for careful tools. By catching the faintest red glow, he turned distance into intimacy and antiquity into presence. The recipes that enable that trick are neither hidden nor mystical. They are the plain arithmetic of wavelengths and temperatures, apertures and noise. Yet when they are arranged with enough care, they allow the oldest morning to stand in a room with living minds and be recognized. That recognition is a kind of homecoming, not for him, but for the species that built him. A confirmation that curiosity can fold itself into metal and survive a long winter to meet a light that has been traveling since the first fires learned to burn. He opened a small window in a very old wall, and the room flooded with guests. The first deep field unfolded not as a lonely speck of antiquity, but as a plaza lit by countless lanterns. A massive foreground cluster worked as a sculptor of space, its dark matter halo curving the fabric until light from far behind stretched into arcs and splinters. The view carried both intimacy and vertigo. Intimacy, because the tiny shapes felt close to recognition. Vertigo, because each shape was a city of suns, standing at distances so great that the notion of here dissolved. The surprise arrived not as a single revelation but as density. The youngest morning presented itself as crowded. He studied the arcs first. They were the handwriting of gravity, letters slanted by the pull of mass not otherwise visible. Lensing did more than decorate the frame. It amplified the background, lifting faint galaxies into view like shells cupped by a rising tide. In the contour of each arc lived a map of the cluster's unseen skeleton, a record of how matter gathered even when it chose not to shine. The effect turned the cluster into a giant instrument, an accidental telescope built by nature and tuned by the observatory's calm gaze. Behind that instrument, sources appeared whose light had set out when the first gas was still learning to burn. He looked for the reddest smudges, the ones whose brightness vanished in filters blueward of a certain threshold. That disappearance signaled the bite of intergalactic hydrogen on youthful starlight, a spectral cliff that acted as a clock. Where the drop occurred, age could be inferred. Where the drop shifted, distance could be traced. Photometry built a scaffold. On that scaffold, candidates climbed into the first ranks of importance, objects that might belong to epochs once thought inaccessible. He knew such lists were provisional. He also knew the human heart reacts to firsts with a blend of reverence and caution. The field asked for both. He weighed brightness against size and felt the arithmetic tug at intuition. Some sources shone with a vigor that seemed out of scale with their apparent dimensions. Either they formed stars at breathtaking efficiency, or they carried hidden engines in their centers, compact wells of gravity that fed on gas and flashed as matter spiraled inward. Each possibility was unsettling in a different way. Ferocious star formation implied reservoirs of cool gas assembled quickly in halos that had collapsed earlier than expected. Active nuclei implied heavy seeds learning to grow while the sky was still thick with neutral atoms. The deep field did not take sides. It offered evidence. He watched the light divide itself into colors beyond human sight, a translation of wavelengths into a palette the eye could hold. Reds and oranges wrapped the image, not as decoration, but as an index of time. Here, red did not equal heat. It equaled distance multiplied by expansion, the universe pulling at each photon until its energy softened into longer waves. The palette made a paradox visible. The youngest galaxies wore the oldest color. In their faint halos, a suggestion of dust emerged. Dust is an artifact of endings, forged in the outflows of dying stars and in the aftermath of explosions. To see it so early was to infer that life cycles had already turned and turned again. He asked the data a gentle question about structure. Were these distant knots chaotic or already organized? The answer arrived in profiles and concentrations, in light curves and shapes measured against the instrument's point spread function. Many sources were compact, the kind of compactness that implies a deep potential well and a history of merging or efficient collapse. Some showed hints of disks or irregular clumps, not random spray but sculpted risk, like clay still soft from the potter's wheel. Complexity had entered the scene sooner than memory had been prepared to receive it. He lingered on the foreground cluster, for it offered a second surprise. The same image that delivered the earliest galaxies also captured the mechanics of a structure much closer in time. Its galaxies resolved into fine detail, its intracluster light, a ghostly mist that recorded past collisions. Embedded within this tangle, multiple images of the same background galaxies appeared like refrains in a musical score, spaced by gravity and geometry. Those repetitions were gifts. They allowed measurements of time delay and offered ways to calibrate models of the mass distribution. The first deep field was not only a portrait, it was an instrument test for the cosmos itself. He measured number counts, not as blunt totals but as functions of brightness and color, the signature curves that translate into histories of star formation. The counts rose. They kept rising. The faint end of the distribution filled so quickly that extrapolation became a temptation and a concern. If the trend continued beyond the detection limit, the earliest era might be richer than forecasts had allowed. That richness would matter for how the cosmic fog lifted, for how ultraviolet photons escaped their birthplaces and ionized the medium between galaxies. The deep field pressed such considerations into urgency by virtue of its sheer abundance. He considered what was not seen. Absence is a tool when the instrument is honest. Some models had prepared the mind for fewer massive systems that early, fewer bright beacons, fewer signs of processed material. The field did not comply. Yet it also held mysteries of omission. The very faintest dwarfs, those flimsy but numerous counters at the bottom of the mass function, still eluded certainty. Lensing raised a few to sight, but completeness had limits. The deep field taught humility as it delivered awe. It said the record is richer than claimed, and also that patience will be required to finish the census. He set aside the spectacle long enough to admire discipline. Every arcsecond of the image came from exposures stacked with a steadiness that defied the nervousness of space. Guiding stars were watched without blinking. Thermal gradients were held in check. Detectors were read out and reset with routines tuned to avoid ghosting and persistence. The beauty arrived on screens, but the truth arrived in calibration files and noise models and skyflats. The first deep field would become a reference, not only for wonder but for method. Others would return to it to test algorithms and challenge priors. It would be quoted not in words but in counts and curves. He thought of the image as a time machine and as a microscope, a dual identity rare in instruments. The time machine aspect was obvious. Light took the long way around to arrive here, and the frame collected those travels. The microscope aspect lived in the sharpening and the lensing. Small structures appeared as if one had leaned too close to a painting and could see the brush strokes. Star clusters within far galaxies hinted at themselves. Clumpy rings and bars whispered possibilities. Though confirmation would need spectra and deeper visits, the first impression took hold. The dawn did not lack texture. He listened to the reaction in rooms where people had mapped this territory in their minds for years. Surprise carried a trace of relief. It is easier to forgive models for being too conservative than for being opulent without cause. A conservative timeline is a posture of caution, yet caution must yield to measurement. The first deep field spoke the soft language of data and asked that confidence adjust. In that adjustment, there was no loss of dignity for past expectations. There was only the renewed health of a field that lives by admitting when the sky offers more than anyone asked. He traced the sharp edges of spectral drops across candidates and imagined the future spectroscopy that would pin them to exact ages. The promise felt solid. Confirmation would either raise the stakes or revise the excitement, but even revision could not erase the crowd. The crowd itself was fact. The arcs were fact. The shapes were fact. The ghosts of dust were fact. On those facts, the rest could be built or rebuilt. It is not common for one frame of sky to tilt the axis of a debate. Here, that uncommon event felt routine, almost gentle, cloaked in the modesty of a square image, with a dozen bright stars and 100 delicate secrets. He allowed himself the simplest conclusion the scene allowed. The first deep field showed a universe that began to organize aggressively, not recklessly, but decisively. Gravity had no patience for leisurely schedules. Gas found the cool, and the quiet gathered, ignited, and spoke in ultraviolet syllables that time stretched and dimmed but could not erase. The foreground cluster collaborated, bending the way to make sure the whispers were heard. The observatory held its breath long enough for the whispers to turn into sentences. The sentences will lengthen with spectra and surveys, but their first words have been spoken. The shock is not loud, it is exact. He studied the small red embers and realized they were not small. The light suggested youths, but the numbers whispered maturity. Compact knots glowed with a steadiness that implied large reservoirs of stars already in place, their mass-to-light ratios hinting at histories more complex than a first ignition. Photometry across multiple infrared windows gave the clues. A drop in the blue filters, then a rise, then a subtle shoulder, where an older population could leave its mark. He fit models to those colors, and found that a surprising fraction of candidates preferred solutions with significant stellar mass assembled in a brief slice of early time. The picture refused to be a story of first sparks. It pointed instead to furnaces already banked and efficient. He compared size to brightness, and found the paradox sharpen. The half-light radii were tiny, sometimes only a few hundred parsecs when corrected for distance and instrument blur. Yet the luminosities were too large for such small lanterns, unless star formation ran at rates difficult to square with gentle feedback. A small galaxy with a large appetite must feed without choking on its own radiation and winds. In some frames, the profiles were almost stellar in their compactness. But the light was extended enough to betray structure. There was no easy dismissal that the objects were simply stars or artifacts. They were systems, and they behaved like overachievers. He watched the candidates separate into two broad temperaments. Some were brilliantly blue and the rest ultraviolet, the signature of short-lived massive stars pouring out photons as if there were no tomorrow. Others revealed hints of a break at longer wavelengths, a shape that could arise if older stars had already left the main sequence and cooled, or if nebula lines inflated the apparent brightness in the redder channels. Each possibility carried its own lesson. An older population would compress timetables. Strong nebula lines would signal dense gas clouds powered by relentless star birth. Either way, the simple idea of a gradual onset had lost credibility. He considered the arithmetic of halos. Gravity does not play favorites, yet it keeps a book. For a stellar mass to exist, a halo of dark matter must have collapsed to host it. The abundance of halos at such early redshifts drops steeply with mass, a slope so severe that large hosts should be rare. If the luminous objects were as massive as their colors suggested, then either the halos assembled unusually fast or the conversion of gas to stars operated with audacity. The product of halo mass and efficiency must match the stars in place. The efficiency implied by some fits grazed the limits allowed by the cosmic inventory of baryons. The universe had not violated its budget, but it had spent aggressively. He thought about how light can lie when it is not read carefully. Nebular emission can masquerade as a smooth continuum and trick models into inventing older stars. Dust can tilt colors and pretend to be age. AGN can inject a power law that mimics a population in transition. He treated each suspect with suspicion. Spectra that isolate lines help, and narrow filters help, and lensing that magnifies without mangling helps. Yet uncertainty breathes in all early work. That breath did not erase the basic impression. Too many candidates, too bright, too compact, too sure of themselves. The precise figure attached to a given source could move, but the statistical weight pressed in one direction. He measured the surface brightness and felt the constraint harden. Distant galaxies suffer from dimming that scales with distance and expansion together. To be seen at all, they must be either magnified by a foreground lens or intrinsically intense. Lensing explained some of the overachievers and provided a delightful bonus where multiple images allowed consistency checks. Many remained unlensed and still defied modest interpretations. Their star formation rates, when converted from ultraviolet luminosities, suggested a mode of assembly that tolerated little delay. Gas had fallen, cooled, and converted with a speed that crowded our timeline. He ran through the old villains that often haunt early claims. Low redshift interlopers can fool selections if they wear strong lines just so, or if dusty older galaxies peek through the filters in ways that mimic dropout signatures. Morphology helps to weed them out, and spectra help further. Clear Lyman alpha suppression strengthens the case for distance. In the cleanest examples, the balance of evidence aligned with youth in the cosmic sense and maturity in the galactic sense. The deep field was no longer about a single shocking image. It had become a pattern of results that repeated from patch to patch, survey to survey, even as techniques and teams varied. He studied the compactness and thought of black holes. A central engine can add light and harden spectra. If supermassive seeds had already taken root and begun to feed, their emission could bias stellar mass estimates upward. Yet they also leave fingerprints. Broad lines and hot dust betray them when the signal is strong enough. In several of the boldest candidates, the spectra so far looked dominated by stars and nebula gas. That did not acquit every object, but it weakened the defense that a fleet of small quasars was pretending to be stout galaxies. The suspicion remained in the background, like a shadow that must be checked again with deeper looks. He weighed the timescales. The interval between the first collapse of gas clouds and the observed state of these sources was short by any human standard. Hundreds of millions of years is plenty of time for gravity, but it is not infinite. If stars had already died and returned metals to the medium, if dust had already condensed and reddened continua, then a full cycle of stellar life had already run at least once, perhaps more than once, in environments without a pre-existing chemical inheritance. Such cycles accelerate cooling, hasten fragmentation, and change the masses of stars that form next. A feedback loop might explain the efficiency, but it required a first spark capable of igniting quickly in pristine gas. Population 3 stars had long been proposed as such sparks. Their fingerprints are elusive, but the theatre felt prepared for their brief performance. He examined profiles that hinted at clumps and tried to decide whether they were mergers or instabilities. In a universe where everything is closer together in co-moving terms, encounters should be common, and the assembly of galaxies by repeated union should be vigorous. Mergers can drive gas to the center and ignite starbursts that mimic or exceed steady disks. Clumps in turbulent disks can also collapse to form stars efficiently without a violent collision. Distinguishing the two paths is difficult at the resolution on offer, but either path produces speed. The early universe did not need to wait for stately, thin disks to spin themselves quiet. It could build mass through rougher music. He looked for the quiet end of the distribution and found it underrepresented. Quiescent galaxies at these redshifts would tell a different story, one of early formation followed by early rest. A few candidates whispered of that possibility with redder colors and compact cores. If confirmed, they would complicate the narrative further. To shut down star formation so early requires either the exhaustion of fuel or the imposition of an energetic brake. Either path raises the level of organization the universe must have achieved while still young. The small sample invited caution, yet the very existence of such candidates made the mind rehearse scenarios where feedback from stars or black holes cleaned house before the neighborhood had matured. He returned to the tally and felt the cumulative surprise. If even a conservative fraction of the bright, compact sources were truly distant, then the luminosity function bends upward, where theories had predicted a leaner harvest. The bend need not be catastrophic for models to feel the strain. Small adjustments might accommodate the bulk, perhaps through tweaks in star formation efficiency or dust properties or the stochastic nature of bursts. But some objects sat far enough above the expected line that adjustments began to look like revisions. The balance between humility and boldness is the daily work of interpretation. Here, the balance tilted toward admitting that the dawn was industrious. He let the narrative sit in the mind as a physical intuition. Imagine clumps of gas in dark halos falling together in a high-pressure world where densities run higher and cooling paths are efficient once any metal exists. Imagine turbulence that refuses to dissipate and instead seeds dense pockets where stars ignite in quick batches. Imagine feedback that is strong but channeled, carving vents without snuffing the flame. Imagine a central object gaining weight from a rain of cold streams that thread the halo like rivers through mountains. The visualization does not replace the analysis, but it gives the analysis a posture to inhabit. The posture is urgency without panic, speed with control. He allowed a simple sentence to form from the complexity. The earliest galaxies that can be seen look older than their youth permits. The evidence rests in mass estimates that seem high, sizes that seem small, luminosities that seem bold, and spectra that seem seasoned. Errors will shrink and some candidates will fall away. Yet the core impression appears resilient. In the first few 100 million years, matter learned quickly how to shine as an organized community of stars. That lesson, written in compact red gems against a dark canvas, offers not a contradiction to the nature of gravity, but a reminder of how decisively it can work when conditions conspire in its favor. He turned light into syllables. Not the broad vowels of images, but the consonants of spectra, where meaning sharpens. A slit or a microshutter opened on a distant ember, and the glow unraveled into a barcode of brightness and darkness. In that barcode, time presented its credentials. There, a sudden cliff where flux fell to nearly nothing. There, a quiet plateau where it resumed. The cliff marked the appetite of intergalactic hydrogen. The plateau marked the starlight that survived. The position of that edge along the infrared axis was a ruler laid against the universe. Measured carefully, it returned an age, a distance, and a correction snuck into the margins of the calendar. He sought the drop first, the clean signature of young light cut off blueward of a critical wavelength. The feature was not decorative. It was geometry married to chemistry. Expansion conspired with hydrogen's simple habit of swallowing short waves. When the edge appeared at longer and longer wavelengths, the source lived further and further back. Photometry could guess. A real spectrum could swear. One by one, candidates that had been crowned with cautious numbers received confirmation, and in their confirmations, time itself moved. Landmarks once plotted at safer delays slid closer to an origin that suddenly felt less remote. He welcomed lines as well as breaks. Nebular oxygen rose like twin spires in the near-infrared, a pair whose separation became a fingerprint for distance when the doublet could be resolved. A green forest in nearby galaxies, the O3 complex, shifted into a crimson grove here, accompanied by the bell of hydrogen recombination, H-beta or H-alpha, each a record of electrons falling home. Their positions yielded redshift as cleanly as a postal code. Their strengths told of gas lit by young stars and of crowded regions where photons worked overtime. Equivalent widths ballooned, sometimes so large that entire filters in the imaging cameras had been quietly inflated by line light masquerading as continuum. He learned to correct the pretending. Spectra revealed when a broad-band brightness spike was not age, but the sum of a few enthusiastic lines. Photometric fits recalibrated under that influence, stellar masses revised, star formation rates refined, and uncertainties trimmed. Yet even after the corrections, the haste of assembly remained. The calendar did not snap back to its old layout. It stayed altered, the dates of first complexity circled in a red deeper than it had worn before. The message was not that errors had tricked the field into excitement. The message was that the excitement could now be measured. He listened for silence where a line should be, and read meaning there too. Lyman Alpha, the oldest confidant of high redshift studies, often failed to appear. Its absence was a presence of another kind, the mark of a fogged universe where neutral hydrogen still choked resonant light. When the line did surface, it emerged attenuated, its red wings stretched, as if it had swum through syrup to reach the observer. The shape of that stretch hinted at the clarity of the medium between galaxies. A more neutral intergalactic sea thickened the profile and shifted its peak. In those shapes, the state of dawn's air could be inferred, the progress of reionization penciled on the same calendar the distance measurements had just amended. He admired how spectra could weigh temperatures by asking oxygen and neon to speak of their electrons' excitement. Ratios between lines tested the metal content like a palate distinguishes salt from sweet. Low metallicities announced themselves through hard radiation fields and line patterns characteristic of young, lean chemical diets. The results suggested stars born in gas that had barely known previous generations, and yet those very lines were metals, proof that some ancestors had already lived and died. The paradox of youth carrying its own eulogy reappeared, softened by the logic that even a single early wave of massive stars could seed an entire neighborhood with the elements that make cooling easier. He watched for subtler contours, the rise and fall around longer wavelengths where older stars can carve a gentle step known to patient modelers. A Balmer break hinted at populations that had grown past their first furious blaze. When spectra carried that step, the age estimates pushed toward maturity, toward tens or hundreds of millions of years already spent. Age, in this context, measured from a beginning that itself had only recently come into view. The arithmetic condensed lifetimes. A galaxy shining at a redshift, placing it a few 100 million years after the first expansion could bear signs of a workforce that had been hiring for far longer than naive schedules would allow. He used integral field data to map lines across tiny smudges, turning points into postage stamp cubes where every pixel held its own spectrum. The cubes revealed gradients in ionization, small offsets where hot regions snuggled next to calmer ones, whispers of rotation, hints of outflows. Even at resolutions that could not yet read the script of individual stars, the pattern spoke of organization. One knot might favor oxygen, another might glow more strongly in hydrogen, together composing a score where winds and density shaped the melody. This was not chaos. It was the poetry of pressure and radiation written in miniature. He checked motion in the redshifts themselves, tiny shifts along the wavelength axis that could mark gas streaming toward or away, or the stir of a potential well-broadening lines into near invisibility. Velocity widths betrayed turbulence and mass in ways that images could not. When the widths swelled, they told of crowded, active districts. When they narrowed, they whispered of calmer, thinner parishes. In some spectra, a faint asymmetry in a line profile suggested gas leaving the scene, perhaps driven by the very newborn stars that had just lit the place. Feedback was not a footnote. It was a cycle underway, even while the universe wore the bright collar of its youth. He searched for rare signatures that would hint at even stranger histories. A helium line, faint and elusive, would have sung of extremely hot stars with few metals, the kind of population theorized for the first generation. He found frustration more often than satisfaction, the line buried in noise or absent entirely. Negative results are still honest. Their honesty redirected longing away from wishful identifications and toward deeper exposures, better masks, steadier stares. The calendar cannot add a feast where only a rumor exists. It can, however, leave an empty chair and a name card waiting. He pulled back to count the victories. Spectra had purged the lists of impostors that play at distance by wearing convenient colors, revealing them as nearer galaxies with clever disguises. Spectra had confirmed the truest elders, anchoring them with precise redshifts and securing their places at the head of the timeline. Spectra had measured line ratios that set limits on metal content, pressure, and the softness or hardness of stellar radiation. Spectra had traced the meaning of Lyman Alpha's muteness and murmurs, converting profiles into a barometer of a universe in the act of clearing its throat. Numbers replaced adjectives, dates replaced hunches. He allowed the simplest arithmetic to carry the most profound consequence. The shift of a line from one wavelength to another by a factor of 1 plus redshift is not philosophy. It is multiplication. Yet in that multiplication, the history of everything adjusts. If a galaxy sits at a redshift higher than expected, it lives earlier than notebooks had penciled in. If it also carries metals and a population of aging stars, the distance between first ignition and present observation narrows to an interval that forces swifter growth, more efficient cooling, or both. The redated landmarks cascade. The first pockets of clarity in the fog appear sooner. The energy budget shifts. The schedules of black hole seeds, of dust formation, of bursty star formation change together. He put the new entries on the calendar and felt the strangeness settle into normal. The timeline now bore a set of points closer to the origin, decorated not by speculation but by spectra. It did not erase the past work of images or simulations. It harmonized them under a sharper key. Where photometry had sung a melody of possibility, spectroscopy added rhythm and meter. The dawn no longer drifted. It marched. The steps were small, each line a millimeter on a graph, each break a number in a table. But added together, they moved the horizon. The universe's first morning, once imagined as a dim drift of trial and error, acquired timestamps, credentials, and a voice that could be quoted. He closed his shutters on one target and opened them on the next, the practice of confirmation becoming its own liturgy. Far from drama, he found a quieter triumph. The oldest light could be asked specific questions and could answer with precision. The transcript of those answers accumulated as tables and plots, yet the sensation they delivered was human. The calendar had changed. Not rewritten, not broken. Changed. As a map changes when a coast is charted with new detail, a bay discovered, a strait measured. The voyage feels shorter afterward, but the sea has not moved. It is the navigator who now knows where to point. He searched for a clean beginning and found a sky already smudged. Dust, the quiet residue of violence, appeared in the colors of the youngest galaxies, as surely as breath clouds a mirror. The clue first hid in slopes. The ultraviolet continuum leaned redder than pristine gas would allow, a tilt measured by a spectral index that astronomers learned to read like weather. A steeper index hinted at grains suspended in the light, grains that scatter and swallow blue photons more eagerly than red. The implication was audacious. If dust existed, then metals existed. If metals existed, stars had already lived fast, burned hot, died hard, and returned their fragments to the medium. The very idea of an untouched dawn dissolved into a scene of quick alchemy. He traced the alchemy to its likely forges. Massive stars, the kind that die in a few million years, are factories for heavy elements and candidates for the first dust makers. When such stars explode as core-collapse supernovae, the blast throws out calcium, silicon, carbon, oxygen, and iron into a shell that cools as it expands. In that cooling, atoms can assemble into solids. Silicates condense, carbon grains nucleate. Shocks from the same explosion can also break what was just made, a harsh balance between growth and destruction that depends on density and time. If grains survive the chaos and drift into calmer gas, they can seed further growth by accreting metal atoms like frost thickening on a window pane. In that two-step dance, a population of grains can reach the masses implied by the reddened slopes and muted lines. He looked for signatures more direct than color. Fine structure emission from ions, bright at far infrared wavelengths, can act as a lighthouse for metals. In distant sources, the O3 line at 88 microns and the C2 line at 158 microns shift into bands that instruments can catch if the cold and the sensitivity cooperate. Detections of such lines advertise not only enrichment, but the presence of cool neutral gas where star formation can proceed. A bright C2 whisper can sketch the outline of early disks and clumps, a rotation curve in miniature. The presence of these lines at times close to the first few 100 million years tells a simple truth in a quiet accent. Nature had already minted the raw materials for complexity and spread them through the rooms where light learns to speak. He listened for dust through its own warmth. Grains absorb energetic photons and re-radiate in the far infrared, a glow whose peak marks a temperature often between 20 and 50 Kelvin. That thermal murmur, redshifted into wavelengths accessible to submillimeter observatories, can reveal hidden star formation that ultraviolet light alone would underestimate. In the faint dawn, even a hint of such a murmur carries weight. It says that the earliest galaxies were not transparent workshops. They were factories with soot on the rafters. Attenuation turned part of their output inward, and the lost light emerged as a low, patient heat. He weighed the speed required to build this soot. One traditional source of dust, the winds of asymptotic giant branch stars, need several 100 million years to contribute. That calendar is tight in a universe still in its first moments of organization. Supernovae, by contrast, can deposit grains within a few million years, fitting easily inside the window. If early supernovae were efficient producers, and if grain growth in dense clouds accelerated the process, a brief frenzy could suffice. That scenario asks for a bursty population of massive stars, perhaps the kind imagined for the first generation, metal-free and top-heavy in their mass distribution. Their short lives could seed the medium with the first solids and set the stage for more conventional cycles soon after. He followed how dust changes the music of star formation. Grains catalyze molecules by providing surfaces where atoms can meet and bind. Hydrogen, reluctant to assemble in the gas phase, finds it easier to become H2 on a grain, and molecular hydrogen is a vital coolant at low temperatures. Cooling, in turn, allows gas to collapse into denser structures where stars ignite. In that sense, dust invites more dust by encouraging new generations of stars that will end as additional sources of metals. At the same time, grains can block the very light that makes galaxies visible in the ultraviolet, hiding star birth from simple counts. The balance between help and hindrance is a practical puzzle. Estimating how much light is missing requires models for geometry, grain size distributions, and scattering angles, all uneasy in such young systems. He examined lines for the mark of dust on the ionized gas that bathes bright regions. Recombination lines of hydrogen can be compared to one another to diagnose reddening. When the ratio deviates from the pure case B expectation, grains are intervening, eating more blue than red. If the deviation is large, a cloak of dust lies between stars and observer. In the highest redshift sources, these tests are challenged by sensitivity, yet hints accumulate. Modest reddening emerges, sometimes more than modest, forcing revisions to star formation rates that climb when the missing light is restored. He listened for a different messenger. Polycyclic aromatic hydrocarbons, ring-shaped molecules built from carbon and hydrogen, resonate when bathed in ultraviolet light and emit in mid-infrared bands. The presence of these bands can signal both enrichment and a relatively gentle radiation field that spares the molecules from destruction. In the earliest galaxies, the bands weaken or vanish, perhaps because metal budgets are lean, perhaps because hot young stars or active nuclei destroy the fragile structures. Their absence, paradoxically, is a statement. It says the chemistry is still young or the environment is harsh. Either way, it confirms that the dust is not yet the blended, mature mixture found in quieter, later disks. He questioned which grains dominate. Extinction curves differ by environment. In some galaxies, a prominent bump around 217 nanometers betrays small carbonaceous grains. In others, the curve rises smoothly, hinting at silicates and a different size mix. Translating these patterns to the dawn requires caution, but patterns still whisper. A steeper ultraviolet extinction could imply more small grains. Flatter curves might point to coagulation in dense clouds or the selective destruction of delicate particles in intense radiation fields. The curve matters because it shapes the corrections applied to observed light, and because it sketches the life story of the grains themselves. He counted consequences for the big picture. Dust dims, but also protects, allowing cool clouds to survive near fierce stars. It alters the escape of ionizing photons, the very light responsible for lifting the cosmic fog. If grains are abundant and geometry is tangled, fewer hard photons may reach intergalactic space. That constraint complicates the schedule for reionization and shifts attention toward low-mass galaxies with porous structures, or toward windows in time when feedback carves channels through which photons can flee. Conversely, if dust is clumpy and leaves holes, the escape fraction can remain high, even in dusty systems. Measuring this balance is a work of patience, but its stakes reach beyond the census of grains. The temper of the universe's first clear morning depends in part on the soot from its first fires. He watched the way dust reshapes temperatures. Grains mixed with gas can mediate photoelectric heating in neutral regions, and their presence changes the equilibrium of clouds. The ratio of C2 to far infrared continuum becomes a diagnostic for the efficiency of that heating. High ratios hint at extended, less dusty photodissociation regions. Low ratios may mark intense starbursts where dust traps radiation and raises temperatures, while line cooling becomes less efficient. In the dawn, both moods appear. Some tiny galaxies sing loudly in C2, others hum more softly and glow instead as compact, warm spots. He confronted the counter-argument that colors can deceive without dust. Young, extreme populations with very hot stars can tilt spectra, even in the absence of grains. Nebula continuum can fill in troughs and reshape slopes. Careful spectroscopy sifts these influences, and still the dust returns, a recurring presence that refuses to be dismissed. Occam is not offended by a little soot when so many independent indicators agree. The simple story of a pristine sky finds less room to stand. He considered time as a craftsman shaping grains. In dense interiors, coagulation can grow small particles into larger aggregates. In shocks, sputtering can erode them. In the faint early disks, turbulence may mix them unevenly, creating pockets where chemistry runs ahead. A single supernova remnant can act as a laboratory. The ejecta cool, dust forms, a reverse shock propagates, some grains shatter, some survive, and the survivors ride the flow into the surrounding medium. Multiply that by many events packed into a short interval, and a plausible history of early dust emerges. Not smooth, not gentle, productive. He let the simplest sentence remain visible. The youngest structures look lived in. They carry smoke from earlier fires. Grains float in their light, modulating color, guiding chemistry, shaping what can be seen and what must be inferred. That smoke does not obscure the wonder, it enriches it. A clean dawn might please a taste for purity, but the universe favors outcomes where creation and residue arrive together. Stars form. Stars die. Dust accumulates. New stars use that dust to cool and gather. The loop closes, then repeats. In that loop, a sky that should have been pristine became textured before anyone expected, and the texture taught that beginnings rarely come unstained. He counted the brightest knots and wondered what burned at their centers. Some lights behaved like furnaces alone, the blue breath of hot stars pouring across space. Others carried a different heat, a steadier blaze that suggested a compact heart where gravity ruled without compromise. The signs were quiet rather than theatrical. In the near-infrared, a smooth power law rose through the starlight like a tide lifting every pixel. In the mid-infrared, warmth hinted at dust so close to a central engine that grains glowed as if held before a coal. The glow did not flicker with the restless rhythm of star formation. It held its tone, a hum consistent with matter falling inward and shedding energy in a last protest against the fall. He looked for lines that sharpened the suspicion. High ionization features, the kind stars rarely sustain, appeared like neon notes over a deeper chord. Carbon-4, nitrogen-5, helium-2. Their strengths, when measured against hydrogen, outpaced what a young stellar population could supply. In some targets, the profiles hinted at breadth, thousands of kilometers per second in gas that orbited close to a small, deep well. Where the signal fell short for a broad chorus, narrow lines still traced a hard radiation field and crowded densities. The finger pointing to an active nucleus did not wag wildly. It merely insisted. He checked for the most direct witness and found a puzzle. X-rays should accompany a feeding black hole like the hiss accompanies steam. Surveys sensitive to that high-energy light returned a quieter verdict than expected. Either the engines were dim in X-rays, or they wore thick shrouds that swallowed the hardest photons. Dust can be thin to starlight while gas is thick to X-rays, an inversion that hides growth even as mid-infrared heat betrays it. Compton thick cocoons, where electrons scatter away the story, would fit such restraint. The absence of loud X-rays did not acquit the suspects. It suggested modesty or concealment. He weighed the arithmetic of growth against the calendar that the distances enforced. The mass of a black hole increases exponentially when fed at the Eddington rate, the balance point where radiation pushes outward, as hard as gravity pulls inward. The doubling time under such conditions is on the order of tens of millions of years, a duration small for mountains and continents, but large for a universe still rubbing sleep from its eyes. To reach 1 billion suns before the first billion years closes requires either an early and heavy seed, a long duty cycle of steady feeding, a period of super Eddington appetite, or some blend of all three. The standard menu of physics allowed the dish. The kitchen of the early cosmos had to keep the stove on. He traced the plausible origins of those first seeds. One path began with very massive, very short-lived stars, their cores collapsing into black holes of a few dozen to a few hundred solar masses. In packed clusters, where collisions were frequent and migration fast, such remnants could merge into larger seeds, aided by runaway dynamics and the grip of a deep potential well. Another path imagined a cloud so bathed in ultraviolet light that molecules could not cool it efficiently. Without the coolant, fragmentation was suppressed. The cloud collapsed as a single body and formed a direct collapse black hole, hundreds of thousands of suns heavy at birth. Each scenario came with requirements: metal-poor gas, strong radiation backgrounds, inflows unbroken by turbulence. The universe at dawn could offer such environments in pockets. If even a few pockets succeeded, the rest of the arithmetic eased. He listened for the feedback those engines would generate. An accreting core does not simply swallow. It speaks through winds and jets, through photons that punch holes in dusty curtains and stir the gas that could become stars. Spectra preserved evidence of the conversation. O3. Lines widened in places, as if stirred by outflows. Ratios between oxygen and hydrogen tightened around values that suggested both density and a lack of full chemical maturity. Where mid-infrared colors warmed and narrow lines brightened, the host galaxies often revealed compact components, central knots that could shelter a black hole, and the star-forming rings that both feed and resist it. He considered the relationship between the mass of a central engine and the body that houses it. Nearby, the two scale together with a grace that implies shared growth. At the dawn, the dance partners may have stepped out of sync. In some objects, the engine seemed overweight for such a young host. In others, the host seemed to have assembled stars more quickly than its nucleus acquired mass. Scatter in any emerging relation is expected when assembly proceeds in bursts and mergers. Yet even scatter tells a story. It says the balance seen in mature galaxies did not arrive fully formed. It was negotiated through a sequence of surges, stalls, and exchanges of momentum between stars, gas, and a point so dense that light itself had to bargain to leave. He asked what it meant for the broader atmosphere of the era. If early black holes were common and energetic, their photons and winds contributed to warming and clearing the medium between galaxies. If they were fewer or modest, stars bore more of the burden of reionization. The evidence leaned towards starlight as the principal agent, with nuclei playing local but not sovereign roles. Yet the local mattered. An active core can punch channels through which stellar ionizing photons escape more easily. The architecture of a galaxy around an engine becomes more porous. Dawn did not require kings, but it tolerated princes with influence that extended beyond their borders. He searched the hosts for the streams that would feed such hunger. Cold gas can plunge along cosmic filaments into the center of a halo without shock heating if conditions allow. In such a regime, inflow remains efficient, and reservoirs stay cool enough to settle into a disk or dive inward under gravity. Gravitational torques in merging systems can drive further inflows, piling gas into the heart where the black hole's event horizon waits without hurry. Signatures of these dynamics appeared as clumps, as asymmetric light profiles, as disturbed kinematics in postage stamp maps, where velocity changed across a smear of light. The details wavered at the limits of resolution, but the impression held. Supply lines existed. He revisited the possibility of deception. A compact starburst could mimic certain colors, and a wealth of hot young stars could harden the spectrum enough to fake a high ionization signature. To guard against this, he demanded consistency across wavelengths. A power law continuum in the near-infrared, a warm, mid-infrared bump, high ionization lines stronger than stellar photoionization alone can explain, possible radio murmurs from a small jet, and, if fortune allowed, a narrow but not absent X-ray whisper peeking through. The cleanest examples met these tests. Others blurred the line between starburst and nucleus, a blurring natural in systems where both processes share the same kitchen. He paid attention to time. Variability is a heartbeat for active nuclei, a sign that the emission region is small enough to change quickly. Early targets are faint, and patience is expensive, but hints of change appeared between visits. A small dip in continuum, a slight swell in a line. The cadence was too sparse to build a rhythm, yet even a single stagger suggested life at the center. In a world where every photon carried a premium, this flicker felt like a confession wrung from a reluctant witness. He extended his thoughts to a future messenger. When black holes are born heavy or grow through mergers, they shake space-time with low-frequency waves too slow for ground-based ears. Space-based detectors will listen for those bass notes. A chorus of events from the earliest epoch would confirm a history of collisions and rapid assembly. A quiet background would push weight towards steady, solitary feeding. The sky carries many registers. Some are light. Some are gravity itself rippling like water. A full hearing will require both. He held the simplest possibility and the most audacious side by side. Perhaps the engines are exactly what conservative growth can produce when supply is ample and cooling efficient. Or perhaps the seeds began heavy, born from clouds that refused to splinter. In the most speculative corner, there lived the idea that some black holes were older than stars, formed from density spikes in the first moments of expansion, relics of primordial physics. Such relics would be rare and difficult to diagnose, their properties buried beneath layers of later growth. The evidence in hand did not require them. It did not banish them either. In this arena, humility is the correct uniform. He allowed a summary to settle without fanfare. Compact, luminous sources at the universe's first morning carry signs of hungry cores. Their fingerprints include hard lines, warm dust, smooth continua, and occasional motions that widen the script. The growth they imply fits within the budgets of physics, provided seeds form early, food arrives often, and radiation's pressure does not always win the argument against gravity. Where they sit inside their hosts, they stir the gas, shape the exits for light, and trade energy with the very clouds that make stars. They do not demand a cosmos ruled by monsters. They do insist that breakfast was served to some at an hour when the table was barely laid. He counted stars as one counts rain on a roof, by rhythm and intensity rather than individual drops. The rhythm sounded fast. The intensity sounded high. In the faint red systems at the edge of visibility, starlight rose with the urgency of weather fronts. Ultraviolet luminosities translated into star formation rates that, even after careful correction for dust and line contamination, implied factories running near capacity. The light did not come from leisurely workshops. It came from foundries where gas turned into stars with disarming efficiency, where depletion times were short enough to suggest that fuel and fire met with little bureaucratic delay. He considered why speed might be natural. Gas fractions in young systems tend to be large, the reservoirs fresh and deep. When a disk is rich in gas, gravity can defeat pressure more easily, and patches of the medium stumble into collapse. The Toomre parameter, that quiet balance between shear, pressure, and self-gravity, tips below unity, and the plane fragments into clumps the size of small galaxies. Those clumps ignite, become nurseries, merge, migrate, and continue the cycle. In such conditions, turbulence is not a nuisance. It is a collaborator. Supersonic eddies compress the gas into dense filaments where stars begin like frost along a wire. He looked for a rule that could hold across scales and found a familiar one repainted. The relation between gas surface density and star formation surface density that holds in nearby spirals could be extended into this early realm if modified by pressure and metallicity. Where gas piled high, star formation rose steeply, but the proportionality tilted toward greater efficiency than in later, calmer disks. The reason may lie in the chemistry. Even a trace of metals, recycled by an early wave of massive stars, enhances cooling. Better cooling keeps clouds cold and fragile, easier to fragment and quicker to convert their cores into protostars. Dust assists by shepherding hydrogen into molecules and by shielding interiors from harsh radiation. The factory gains both tools and shade. He tested the idea of burstiness. If star formation arrived in episodes, bright phases would pepper the census, each a flare that fades when feedback heats and evacuates the fuel. The duty cycle becomes the hidden metronome. A short duty cycle means many galaxies are caught in quiet interludes, and the brightest few dominate the light. A longer duty cycle means a larger fraction are observed in mid-blaze. Variations in this hidden rhythm change the shape of the ultraviolet luminosity function, the index that counts how many bright, how many faint. The early sky appeared to prefer a distribution where flashes were frequent and interludes were brief. He weighed the possibility that the recipe for stars themselves had shifted. If the initial mass function leaned toward heavier stars in these harsh conditions, the ultraviolet output per unit mass would rise. That tilt would make galaxies look especially productive, even if the mass arriving in stars were modest. Evidence for a top-heavy mix, whispers rather than shouts. Hard spectra and extreme line strengths hint at very hot stellar populations, while the absence of strong mid-infrared bands suggests that delicate molecules have not yet tamed the radiation field. No single indicator suffices. Taken together, they allow the notion that the first factories may have favored giants. He searched for the gas that feeds such speed. Carbon in a singly ionized state, glowing in a fine structure line, proved more reliable than carbon monoxide at these metallicities, tracing cool neutral regions where molecules hide, but still allowing a map to be drawn. Where the line shone, it revealed rotating structures the size of small cities, velocity gradients that spoke of ordered motion even amid chaos. The line was sometimes faint compared to the far infrared glow, a sign that radiation fields were intense and that the machinery had shifted into a high gear where traditional coolants were taxed. From these maps he could sketch inflows, circumnuclear rings, and the elongated footprints of clumps, stirring the medium as they orbited. He confronted the heat that might thwart rapid birth. Young stars and their clusters flood their environments with photons and winds. When this pressure grows, gas can be shoved outward. Supernovae arrive as emphatic punctuation, driving shocks and stirring cavities that seem hostile to further collapse. Yet the same feedback can create dense shells in which the next generation forms. Channels open while knots thicken. In some geometries, light flees through chimneys while dense pockets remain sheltered. The balance between disruption and encouragement hinges on geometry, on the timing of explosions, on the clumpiness of the medium. In the early factories, that balance often favored continuity over quenching. He examined outflows as a tax on growth. Spectral lines tilted and broadened, their blue wings reaching farther than gravity alone would allow. These signatures measured mass loading, the rate at which gas escaped compared to the rate at which stars formed. High mass loading can starve a system. Moderate mass loading can prune it into a healthier shape, removing the least bound material and leaving behind deeper wells that continue to feed the central regions. The early skies favored pruning over starvation. Outflows were present, but the factories continued to operate. supplied by fresh inflow along filaments, and by gas funneled inward through talks from clumps and companions. He factored in a background that could not be ignored. The temperature of the microwave sea was higher then, warming dust and setting a floor for how cold clouds could become. Warmer clouds cool less efficiently, which should slow collapse. Yet the evidence for speed persisted, implying that high densities compensated for the elevated floor. The background also glowed behind the dust, reducing contrast in submillimeter observations and making faint heat more difficult to detect. When a signal still rose above that floor, it argued that star formation was intense enough to overcome both the warmth of space and the limits of the instruments. He tracked specific star formation rates, the ratio of current birth to existing mass, and found numbers that exceeded those of later epochs by comfortable margins. Galaxies doubled themselves on timescales not far from their dynamical times, a pace that made growth feel almost alive in the present tense. When plotted against mass, the relation suggested a main sequence of star formers even in this youth, a band where most systems lived, with a scatter towards starbursts that ran ahead of the crowd. The existence of such a sequence meant that the factories obeyed rules, not chaos, and that those rules already resembled the ones that govern calmer eras, simply set to a faster tempo. He explored structure at the margins of resolution. Clumps that held a few percent of a galaxy's mass gathered in rings, or along bars, and then drifted inward, surrendering angular momentum to the outer disk as they moved. Inward migration fueled central concentrations and may have set the stage for compact cores found later. The process happened quickly when gas fractions were high and turbulence strong. The story behind a compact object at early times could therefore be one of internal rearrangement rather than only mergers. The factory was not simply expanding, it was reorganizing itself while it worked. He tested the influence of environment on the escape of the most valuable photons, those with energy enough to ionize hydrogen in the intergalactic medium. Porous factories leak, smooth factories trap. Measurements of the ratio of certain lines to the continuum, of the depth of interstellar absorption troughs, and of the shape of Lyman alpha profiles hinted at geometries with pathways for light. The very engines that cleared channels for escape could be the same engines that kept star formation efficient by venting pressure. A galaxy could thus contribute to the grand shift from opaque to transparent while maintaining its internal productivity. He kept an eye on the arithmetic of fuel. Depletion times appeared short, implying that without replenishment the factories would stall. Streams of cold gas delivered through the cosmic web offered a solution. Where halos were massive enough, shocks heated inflow and slowed the procession. In smaller halos, typical of the dawn, gas could slip in cold and direct, sustaining the flames. The contrast between halos that cut off their supply and those that welcomed it may have set divergent paths early, one toward rapid build-up and early quenching, another toward prolonged adolescence before the quiet set in. He accepted that measurement itself adds noise to the melody. Converting ultraviolet light to star formation rates requires assumptions about dust and the mix of stellar masses. Interpreting line ratios as pressures and metallicities invites degeneracies. The uncertainty did not erase the theme. Independent approaches concurred. Where the line glow was strong, where the ultraviolet slopes tilted blue even after dusk, where the far infrared murmured despite the warm background, the conclusion repeated. Factories worked energetically in the first chapters. He allowed a final image to take hold. Imagine a city lit at night where construction cranes swing over nearly every block, where streets are temporarily walled by scaffolds, where sparks from welders fall like brief meteors, and the noise never fully stops. The city is not chaotic, it is directed. Permits have been issued by gravity, budgets have been approved by cooling. Inspectors named pressure, shear, and radiation visit constantly. In that city, work crews know that the schedule is tight and the ambition large. The skyline changes by the week. The first stars are both architects and demolition experts. Their tools are winds, photons, and heavy elements. The result is a district that grows at a pace the later world would call impatient, but that the early world would simply call normal. He read the sky as a weather report from an earlier climate. The atmosphere then was not air but hydrogen, not clouds but neutral fog stretched between small bright islands. In that fog, Certain photons could not travel far. Each one met an atom ready to catch it, to absorb it, to pass energy inward until the message was lost. When the first sources lit, they carved cavities around themselves, pockets where hydrogen surrendered an electron and became transparent to the most precious light. Those pockets grew, touched, and merged. The result was a change of state as consequential as any season, a transition from opaque to clear that let distant things be seen at all. He named it in the simple language of chemistry and light: reionization. He did not imagine this change as a single sunrise. It came patchy and local before it came global. Around a young galaxy, where stars poured ultraviolet syllables into the darkness, a bubble swelled. The bubble's radius depended on the rate of photon production, on the recombination rate in the gas, on clumpiness, and on how much of the hard radiation escaped the factory walls. He traced escape not as a metaphor but as a number, a fraction between 0 and 1. Carve enough channels through dust and gas, and the fraction rises. Choke those channels with dense clumps, and it falls. Early images and spectra whispered that many factories were leaky. Their geometry was perforated by turbulence and feedback. Their winds had cut vents. Their star clusters had punched holes. Through those holes, light fled, carrying the power to change the medium beyond. He listened for evidence in the language of absence. A spectrum from a bright background source crossed the fog, like a lighthouse beam across mist. Where the beam encountered neutral hydrogen, flux vanished in a long trough. This was the Gunn-Peterson signature, a dip that deepened as the neutral fraction rose. Even a small residue of neutrals could empty broad sections of the spectrum. When the trough appeared, it carried a date in its red edge, the moment when space along that path became opaque. In younger lines of sight, the trough retreated. In older lines of sight, it widened. He charted those retreats and advances as a coastline on a map of time. He followed another indicator, more delicate than a full blackout. The bright emission from hydrogen in the galaxies themselves, Lyman alpha photons, tasted the surrounding medium and suffered in proportion to its neutrality. When the fog was thick, the photons scattered and lagged. Their line profile bloated and shifted if they escaped at all. When the fog thinned, the lines strengthened and sharpened. Counting how often these lines appeared in galaxies of a given age provided a census of clarity. The census did not require brave leaps. It required patience and repetition. That patience yielded a pattern in which the lines became more common as time advanced. A rhythm that placed the clearing of the fog within a few 100 million years of the earliest sources. He accepted that not all architects of transparency were created equal. Small galaxies, numerous and energetic, could contribute many photons and dominate the field by sheer headcount if their escape fractions were generous. Larger systems, rarer but brighter, could make individual bubbles large even with modest leakage. The balance matters. A sky ruled by many small leaks lifts its clouds differently from a sky punctured by fewer, larger chimneys. He weighed number counts, luminosity functions, and estimates of hardness from line ratios. They leaned towards starlight in small and intermediate hosts as the principal laborers, while active nuclei worked locally or in occasional grand gestures. He read constraints from a separate ledger, written at microwave wavelengths. Long after reionization, the remnant light from the hot beginning carries polarization signatures from the last free electrons to scatter it. That polarization encodes an optical depth, a measure of the integrated column of ionized gas back through time. The number is not a portrait, but it is a budget. He compared the budget to the photon economy implied by early galaxies. Within the uncertainties, the accounting worked. With reasonable escape fractions and a faint end of the galaxy population that did not vanish into nothing, the stars could pay the bill. The fog could lift without borrowing from physics outside the established repertoire. He used maps in the making to imagine the dance from another angle. Neutral hydrogen signals at meter wavelengths trace the fog directly. Where the fog is thick, the signal rises. Where it is thin, the signal falls. Interferometers listen for that pattern, building three-dimensional images of the patchy dawn with patience and careful calibration. These instruments, tuned to the soft bass of the universe, will draw the outlines of bubbles as they grow and combine. The expectation is a jagged pattern of brightness against darkness, a network that evolves with redshift as the transition runs toward completion. Light and radio hear the same story in different registers. Together they will tell whether the clearing was quick or staggered, uniform or lopsided. He asked how geometry within galaxies governed the escape. Simulations suggested that feedback from clustered supernovae and the pressure of radiation create low-density corridors through which ionizing photons slip. The corridors do not run everywhere. They are local and angular, and their orientation changes with time as new clusters form. This patchiness means that two galaxies with identical star formation rates can leak very different amounts of hard radiation. It means that instantaneous measurements of escape fraction carry a variance that nature insists on. Observations echoed the lesson, with lines of sight that showed wildly different leakage even in similar hosts. He considered the stubbornness of recombination. Free electrons and protons find each other and reunite, especially in dense clumps. This reunification eats ionizing photons, a tax paid to density. The tax rises with clumpiness. If the intergalactic medium is smooth, the tax is low, and reionization proceeds with fewer photons. If the medium is lumped, the tax is high, and the process drags. Early data on the sizes of bubbles inferred from lines and damping wings hinted that clumpiness was not so severe as to bankrupt the budget. The fog put up a fight, but did not mount a siege. He looked for the fingerprints of bubbles in spectra that skirted bright foreground lenses. In some cases, a background galaxy or quasar traced a cylinder through space, lined with information about its surroundings. When the damping wing of the Lyman alpha line curved a certain way, it suggested the presence of neutral gas outside a local bubble. When the wing relaxed, it suggested a path already clear. The difference between those shapes across multiple sight lines began to sketch the patchwork. Not a picture yet, but the beginnings of a quilt where each square was a measurement with edges that offered to be sewn to the next. He evaluated how dust within the sources might have burdened the effort. Dust absorbs ultraviolet photons, including the ones most valuable for clearing the fog. Too much dust means too few photons escaping, even if star formation is vigorous. Yet dust also fosters star formation by improving cooling and molecular chemistry. The compromise is a geometry designed by feedback. Vents punched through dusty gas can let photons out while dense pockets keep forming stars. The patchwork inside a galaxy mirrors the patchwork outside. When spectra and colors were read with this in mind, the conflict between dust and reionization softened into coexistence. He noticed a tendency for the brightest Lyman alpha emitters to gather in groups, as if their bubbles overlapped more quickly where galaxies clustered. This bias matters. Reionization likely began earlier in overdense regions and reached voids later, a front that moved faster where sources were many and slowed in the deserts between. The topology of this advance can be read in the large-scale distribution of emitters, in the sizes of their apparent proximity zones, and in the statistics of line strength as a function of environment. The evidence pointed toward a universe that cleared itself unevenly in space, while following a smooth global curve in time. He let the notion of speed take on nuance. Fast can mean early in onset, rapid in growth of bubbles, or brief in total duration. The data favored a rise that began not long after the first sources, and a progression that accelerated as more bubbles touched and merged, with completion by a redshift that still sits safely larger than the epoch when galaxies like the Milky Way begin to settle. The timeline left room for regional complexity without permitting a drawn-out struggle. Speed, in this specific history, meant a phase change that was decisive once it gathered momentum. He tested the reach of alternative contributors. X-ray binaries and faint black holes could preheat the medium and make ionization easier by raising temperatures beforehand. The soft glow of their heating would change the shape of the meter wavelength signal, altering contrasts between regions. Supernova shocks in the medium beyond galaxies could assist by producing partial ionization and stirring small-scale structures that change recombination rates. These were refinements rather than replacements for starlight. The pillars of the temple were still young stars, but the frieze along the top carried carvings of other agents at work. He closed the ledger with a picture that required no new laws. Many small galaxies lit the fog with hard photons. Some larger ones helped by building big private bubbles. Geometry and feedback opened channels. Dust muted, but did not silence. The intergalactic medium recombined, but not so quickly that the light fell behind. Polarization of the oldest background light set a total bill that the stars could pay. The meter wavelength maps promised to show the process as patches rather than as an average. The end result was a clear morning in which light could travel, spectra could be drawn without drowning, and distances could be inferred from edges as clean as a cliff cut in glass. He opened a laptop and watched a second universe grow inside a cube of code. Gravity woke first, whispered through a mesh, and pulled dark matter into filaments that thickened like rivers fed by rain. Gas followed along the unseen scaffolding, cooling where density climbed, shocking where flows met, fragmenting when the conditions allowed. Stars flickered on inside subgrid recipes that converted gas to light at rates tuned to obey rules learned from calmer epochs. Supernovae and stellar winds returned energy to the medium in carefully chosen pulses. Black hole seeds arrived by prescription, accreted according to a limited menu of choices, and pushed back with feedback that kept galaxies from bloating. The result was an artificial cosmos faithful to the broad strokes of observation and the quiet power of the current cosmological model. Then a new set of early lights demanded to be included, and the fidelity looked less comfortable. He began with the simplest comparison, the count of bright galaxies as a function of their brightness. The simulated ultraviolet luminosity function bent downward at the top end, a graceful roll shaped by feedback that prevented runaway star formation in massive halos. Observations at the earliest times plotted points above that roll. Not everywhere, not by a factor that mocked the model, yet high enough to feel the strain in the slope. To raise the counts without breaking the rest of the picture, he experimented with star formation efficiency that rose earlier, with cooling boosted by a trace of metals, with gas that refused to be heated long by a newborn population of stars. Each adjustment brightened the top end. Each introduced trade-offs that had to be paid later. He turned to sizes. Simulated galaxies grew compact when gas fractions were high, and angular momentum could be shed through clump migration and minor mergers. Yet the smallest observed cores were smaller still. Their light concentrated inside radii that challenged the usual combination of pressure support and feedback. He increased resolution to let turbulence and fragmentation carve the gas more finely. He allowed star formation to occur at higher densities before feedback ignited. The compactness improved. A new concern emerged. Without careful timing, young stars overcooled their neighborhoods by radiating before feedback arrived, and the simulated factories ran too hot for too long. Numerical convergence, that sober judge of credibility, asked for patience and more compute. He weighed the budgets that tie stars to halos. Abundance matching, a method that marries the rank order of stellar mass to the rank order of halo mass, implied star formation efficiencies that rose unusually early if the brightest candidates were taken at face value. The halo mass function at high redshift is steep, so placing large stellar masses inside the correct number of halos can demand efficiencies near the cosmic fraction of baryons, an extravagance nature is reluctant to afford. He softened the tension by reinterpreting some bright objects as lens-boosted or line-inflated. The remainder still requested efficiencies higher than the models typically grant. He answered by letting cold flows feed the center more directly, and by tempering early feedback just enough to keep gas bound. He tested different feedback scripts. Thermal dumps of energy vanished into numerics unless the local gas was allowed to cool inefficiently for a modest time. Kinetic kicks gave clearer results, blowing holes that resembled observed chimneys and lifting low-density gas where ionizing photons might escape. Radiation pressure acted like a separate hand, gentler but constant, carving cavities before the first supernovae arrived. The combination mattered. Too weak, and galaxies swelled to unrealistic brightness and size. Too strong, and they starved. In the new regime, a narrow middle ground reproduced both the compact light profiles and the steep line equivalent widths without exhausting the fuel prematurely. He listened for metals in the code, because enrichment changes everything. A small flaw of metallicity, added by the first massive stars, transformed the timing of cooling, the mass spectrum of new stars, and the appearance of synthetic spectra. When he inserted early enrichment at a level consistent with modest dust, gas fell inward more efficiently and formed clusters in dense knots. The simulated O3 and H-beta lines brightened and swelled toward the extreme values in the data. The same enrichment raised the far-infrared glow of dust. But the backdrop of the microwave sea reduced contrast at high redshift and kept the synthetic submillimeter maps from violating existing limits. The harmony was imperfect, yet plausible. He confronted the cause. In some early systems, the central surface densities of stars approached values familiar from compact nuggets found at intermediate times. His simulations could reach those densities through repeated inward migration of clumps aided by tidal stirring. Major mergers were not required but helped when they occurred. The same processes seeded massive central objects. When he allowed black holes to start heavier in select metal-poor, strongly irradiated pockets, their growth curves matched the mild, active signatures in the targets. The difficulty was not in reaching a high mass by the epoch observed. It was in doing so without spoiling the stellar assembly around them. Momentum-driven feedback, scaled to the depth of the potential, did a better job than purely thermal models at preserving a compact, star-forming ring around a calm, heavy core. He widened the box to include environment. Overdensities grow earlier and faster. When he selected rare peaks in the initial conditions, the synthetic skies brightened and the abundance of luminous systems increased. Cosmic variance asserted itself. A single deep field could stumble into a lucky corridor of structure and exaggerate the global averages. He measured the scatter across many mock light cones and found that variance could lift or lower counts by amounts similar to the reported surprises. The argument did not free the models from responsibility. It replaced a claim of failure with a request for more fields and a promise that bright patches can be honest exceptions. He scrutinized the spectral energy distributions produced by the code, instrument by instrument. Broad bands were contaminated by lines just as in reality. When he incorporated full radiative transfer with nebular emission, colors slid along vectors that photometric pipelines might mistake for older populations. Spectra in the synthetic catalog corrected some of the inflated stellar mass inferences when lines were properly accounted for. This reconciliation reduced the number of galaxies that demanded extreme efficiencies. It did not erase the upper tail of compact, luminous sources that still strained the calibration. The remaining tension felt more like a challenge to recipes than a rebuke of first principles. He tested initial mass functions that bent toward massive stars in high-pressure, low-metallicity gas. The change increased ultraviolet output per unit stellar mass and produced harder ionizing spectra. The simulated line ratios moved toward the observed extremes. The downside arrived in chemical yields and supernova rates that, if sustained for long, would over-enrich the medium. He solved the excess with a time-dependent mix, top-heavy during bursts, closer to standard during interludes. This flexibility felt speculative but not lawless, an emergent behavior in high-density pockets rather than a global decree. He tuned the escape of ionizing photons by resolving superbubbles and chimneys. The resulting reionization history matched polarization constraints while keeping the faint end of the galaxy population within reason. The code produced patchy maps of neutral hydrogen that future radio arrays could test directly. In those maps, bright early galaxies sat at the centers of overlapping bubbles, while dim dwarfs laced the edges. The topology aligned with the suggestion that clusters of emitters marked regions where clearing began first. Agreement in topology mattered more than exact dates, since dates still wandered with assumptions about escape fractions and duty cycles. He checked numerical sins. Current conditions and resolution limits can hide cooling flows or exaggerate them. Star particles stand in for clusters, and their feedback must be deposited in volumes that the mesh or particles can represent. He pushed resolution until the convergence curves leveled, then verified that the qualitative trends remained when he relaxed the settings. The resilient features included rapid early assembly in overdense regions, compact star-forming cores built by clump migration, high equivalent width lines arising from low metallicity and high pressure, and a tail of bright systems, whose number was sensitive to small shifts in efficiency. He invited a different class of model to speak, the semi-analytic constructions that paint galaxies on dark matter merger trees using algebra instead of full hydrodynamics. These models could be morphed quickly to explore parameter space. When he raised the floor of early efficiency and allowed burst-driven duty cycles, they produced counts and sizes similar to those in the data. The The price was a parameter set that sat near the edge of prior expectations. Edge did not mean impossible. It meant the field would earn its next round of certainty by measuring the same quantities from a different angle. He summarized the posture of the simulations after the challenge. The backbone of the cosmological model remained straight. Large-scale structure, the inventory of matter and energy, and the growth of halos did not require replacement. The muscles and tendons, the recipes that turn gas into stars and return energy to the medium, required training for a faster start. Modest shifts toward earlier enrichment, more efficient inflow in small halos, feedback that vents rather than smothers, and episodic tilts in the masses of newborn stars brought the synthetic dawn closer to the measured one. Some of the brightest cases still stood as provocations that may soften when spectra finish their work. Others will remain as standards for the next generation of code to meet. He let the last frame from the virtual cube fade and considered the simplest claim a model can make. Not that it is perfect, but that it can learn. Each early galaxy that rises above prediction teaches the code where it is stiff and where it can bend without breaking. In those lessons, a simulated universe becomes less an act of imitation and more a device for understanding why certain shapes and numbers appear on the detector. When the device learns to produce compact, vigorous, metal-poor factories early without vandalizing the rest of history, it has not replaced the sky. It has earned the right to speak with it. He entertained the possibility that nature had taken familiar equations and set their dials to unusual positions. The first suggestion came from the invisible scaffolding that guides all structure. If the particles that make up dark matter drift with a trace of warmth, their early motions erase the smallest seeds by smoothing density on fine scales. Fewer tiny clumps at the start could paradoxically help larger halos gather mass sooner by reducing the competition for gas and simplifying the merger tree. Warm dark matter changes the texture of the cosmic web without tearing it. The filaments still form, but their threads are thicker, their knots tighter. Models tuned this way produce larger building blocks early and can lift the brightest systems into view on a shorter schedule. They also suppress the faintest dwarfs, a change measurable by how steeply the number of galaxies rises toward low luminosity. The sky will arbitrate by counting both the spectacular and the modest. He considered a different knob, one that touches the expansion itself. A small episode of early dark energy, active only for a brief window before fading, can tweak the growth of structure by altering how quickly the universe widens. If expansion hastens just so, density contrasts must grow more decisively to keep pace, encouraging halos to collapse earlier once the episode ends. The adjustment is not large in amplitude, but is large in consequence. It pushes schedules, not laws. In some versions, the same change threatens to disturb the exquisitely measured ripples in the cosmic microwave background. That tension is not a disqualifier. It is an invitation to precise accounting. The universe tolerates audacity only if it balances all ledgers. He moved from the fabric to the fuel. The mix of stellar masses born from a cloud shapes the light for millions of years afterward. If the initial mass function tilted toward heavier stars in the pressure and radiation of early environments, ultraviolet luminosity per unit stellar mass rises. The same tilt hardens the ionizing spectrum and accelerates enrichment, explaining strong lines and quick dust without resorting to extraordinary efficiencies. A top-heavy mix is not a fantasy. Gravity, cooling, and turbulence together set the mass scale where collapse fragments, and that scale shifts with metallicity and temperature. Yet a prolonged preference for giants would overproduce metals, remnant black holes, and supernovae. A compromise suggests itself. The tilt may be episodic, rising during brief bursts in dense pockets, relaxing toward a calmer distribution as dust and metals accumulate and cooling paths multiply. He asked if light had met the medium differently than usually assumed. Recombination, the process that once tethered electrons to protons after the hot beginning, controls how transparent the cosmos becomes. Variations in the background radiation or in the abundance of exotic particles could have nudged the timing of that tethering, leaving small fingerprints in the ionization history that echo down to later times. Non-standard recombination may modestly raise the free electron fraction, altering cooling in the first clouds and the coupling of gas to the cosmic microwave background. Even tiny changes at that stage propagate. Their test is merciless. The microwave sky remembers its childhood with precision, and any alteration must pass that memory's interrogation while offering something useful in the theatre of early galaxies. He listened to gravity's more radical cousins. Modifications to the inverse square law, or to the way curvature responds to mass at low accelerations, have been offered as alternate explanations for the motions of stars in galaxies. Such proposals usually aim at the later universe, where disks rotate and halos lounge. At dawn, they risk changing the rate at which small halos grow and merge. Increased effective gravity at low acceleration would quicken early assembly. Decreased gravity would slow it. The test is not only whether the first luminous knots appear on time, but whether the large-scale skeleton that bears them continues to match the delicate pattern of clustering seen in surveys across cosmic time. Elegant formulas that cure one ache can introduce new pain elsewhere. He revisited time's earliest fraction, when quantum fluctuations were stretched to astral size. The spectrum of those primordial ripples is nearly scale-free, but not exactly. If inflation left a slightly different tilt or a small wiggle, some scales would enjoy a head start. A bump at the masses that later house the first bright galaxies would ease their rise without touching larger structures. The idea is specific enough to be falsifiable. It predicts a pattern in the abundance of halos that future weak lensing maps and deep surveys can weigh. The cosmos keeps excellent minutes. Any revision to the agenda must appear consistently in those minutes. He questioned whether black hole seeds could have begun more corpulent than usually supposed. Direct collapse in metal, poor, intensely lit clouds can produce objects hundreds of thousands of solar masses at birth. Such seeds flatten the growth curve, giving modest accretion histories room to yield impressive engines by early times. Their hosts would carry the mark of strong radiation fields that suppress molecules, and their neighborhoods would prefer configurations where nearby sources bathe the gas in ultraviolet light. Evidence for these conditions would include deficits of certain molecular lines and geometries that favor inflow without fragmentation. The engine then becomes not a miracle but a beneficiary of unusual weather. He asked chemistry for an unorthodox ally. If cooling at very low metallicity is more efficient than appreciated, perhaps mediated by molecules or dust produced in supernovae with higher yields than the median, clouds fragment earlier and more finely. The better the cooling, the quicker gravity carves the medium into cores. Laboratory work on grain condensation in ejecta and detailed models of shock processing will refine these yields. The implications are concrete. A minor adjustment to how quickly dust grows in dense gas can reconcile the presence of soot, extreme line strengths, and brisk star formation without asking halos to break statistical laws. He weighed the role of geometry at cosmic scales. If the brightest fields happen to lie behind exaggerated gravitational lenses more often than assumed, magnification bias would inflate counts of luminous sources. The bias could arise if the earliest galaxies cluster preferentially behind oversized halos, or if subtle selection effects favor lines of sight that already enjoy help. The correction is observational. Map foreground mass more completely, model the lenses with care, and verify whether the counts shift. Nature sometimes places a thumb on the scale through alignment. The cure is to recalibrate the scale. He entertained a quieter possibility that refuses glamour. Perhaps the observations are mostly correct in spirit, and the models mostly correct in soul, and what remains is a thicket of small systematics that point in the same direction. Photometric redshifts can be biased by hidden lines. Stellar masses can be inflated by uncorrected nebular emission. Sizes can be underestimated when surface brightness dimming hides faint wings. Duty cycles can fool luminosity functions if bursts are common. Clear spectra, longer integrations, and better image reconstruction chip away at the thicket. The surprise then remains, but shrinks from crisis to revision. He explored a speculative trail where gravity's seeds predate atoms. Primordial black holes, born from density peaks in the first instant, could provide rare, heavy anchors around which gas organizes quickly. Their abundance must be small to avoid contradictions with lensing and radiation constraints. A small abundance is enough for influence in select neighborhoods. Their telltales would be subtle, anomalous microlensing events in early arcs, unusual ratios of X-ray to infrared light if they feed in pristine environments. The scenario does not excuse the cosmos from building most structure with ordinary cold, dark matter. It adds occasional shortcuts that bring a few lanterns forward before the streetlights are wired. He asked whether gravity waves could adjudicate some of these arguments. If early black holes formed by frequent mergers in dense star clusters, space itself would have rung with a background of low-frequency waves. If instead heavy seeds appeared nearly whole and grew by slow accretion, the background would be quieter, punctuated by rarer, heavier collisions as halos merged. Listening for this baseline will not confirm warm dark matter or early dark energy. It will map the family history of compact objects, a clue that cross-checks how quickly centers matured compared to their hosts. He returned, finally, to the equations themselves. General relativity, hydrodynamics, atomic physics, and radiative transfer do not break under the strain of early structure. They do insist on initial conditions and parameters. Within those, the room for adjustment is real. Change the mixture of star masses briefly. Allow dust to condense faster in dense pockets. Permit select halos to enjoy direct collapse conditions. Tweak the small-scale power without violating the microwave background. None of these alone is a silver key. Together they form a ring that may open most of the locked doors. The remaining few would either concede with better data or demand bolder architecture. He let one principle hold the rest in its gravity. Explanations that do the least violence to successful measurements elsewhere deserve first trial. Where invention is needed, it should be as light as possible. The dawn of time did not conspire to mislead. It revealed a universe comfortable with speed when density and cooling cooperate. If an extra push from particle physics or an altered rhythm in starbirth smooths the path, it will be accepted only after it sings in tune with every other choir the sky conducts. He assembled listeners rather than lookers. Each listener tuned to a different register of the first morning, and together they formed an orchestra with sections of gold and cryogenic hush. One program drew maps like embroidery along the edge of darkness. Another threaded spectrographic needles through the smallest seams. A third pointed at clusters that bent space into magnifying glass. The names read like quiet vows, deep surveys that would not blink, spectroscopic campaigns that would not guess, mosaics that would not settle for a single square of sky when a quilt could be sewn. He began with a survey that loved patience. Time was poured into a narrow patch until the background fell away and the faintest grains of light could breathe. The method was simple to describe and demanding to sustain. Dither the exposures so that bad pixels do not repeat their lies. Roll the observatory so that diffraction artifacts rotate and can be recognized for what they are. Stack the frames with algorithms that respect the statistics of sparse counts rather than the comfort of Gaussian dreams. Out of the stacking rose a field where galaxies at the threshold of visibility presented themselves with enough profile to be measured rather than imagined. He added a companion project that preferred breadth. A mosaic carried across a wider sky ensured that rare objects had a chance to appear and that cosmic variance could be measured rather than invoked. Tiles overlapped so edges would not fray. Filters alternated so that colors could be compared without time costing the comparison its meaning. The wide survey accepted that it would not capture the faintest whispers. It chose instead to census the bright end with honesty, to lay down the scaffolding of number counts on which the deeper programs would hang their delicate detail. He invited a lensing campaign that turned clusters of galaxies into borrowed telescopes. Space curved around massive foregrounds and brightened what lay behind. The plan required a duet. One instrument mapped the arcs and counter-images in exquisite angular detail, allowing lens models to be tested against the geometry of repetition. Another instrument gathered spectra for the lensed background sources and for the cluster members themselves, pinning distances that the models needed to convert shapes into magnifications. With each refinement, magnification maps sharpened, and with each sharpening, the true brightness of the distant galaxies could be recovered from the tricks of alignment. He leaned on a spectrograph that could open thousands of tiny doors at once. The microshutter array clicked like rain over a metal roof, selecting its targets by a pattern decided hours earlier on Earth. Light slipped through the chosen windows and struck gratings that teased it into bands where lines could stand up and declare their wavelengths. The instrument did not waste a night interrogating a single source. It spoke to many quietly, one exposure after another, building a census of confirmed distances that turned photometric suggestions into measured facts. In favorable fields, the shutters aligned with arcs from lensing, and the same exposure secured a redshift for a galaxy that no unassisted mirror could have seen. He kept a second spectroscopic trick ready for targets too small or too numerous for shutters. Slitless modes spread light from every object in the field, producing overlapping spectra that resembled a sheet of music dropped on the floor. The key was choreography. Observations at multiple orientations separated blends and made it possible to reconstruct clean notes from the mess. Emission lines revealed themselves even when the continuum was faint. Lines at rest wavelengths invisible from the ground became accessible, turning the mid-bands into a registry of heavy elements in their youth, and the near bands into a ledger of hydrogen recombination past the fog. He trusted a camera that could behave like a spectrograph when asked. Grisms behind infrared filters provided low-resolution spectra directly from images, aligning efficiency with discovery. Where broad band colors hinted at a break, the grism verified it. Where a narrow line might be inflating a magnitude, the grism revealed the culprit by unfurling the light just enough to expose the peak. In one sweep, an entire cadre of candidates could be weighed for honesty, and the dominoes of misclassification toppled before they wandered into analysis. He paired the space work with cold ears on a mountain and on a plateau. An array of dishes captured the long whispers of carbon in a singly ionized state and the even longer hum of dust. These maps anchored star formation rates that ultraviolet light alone could underestimate, and traced rotation where starlight was too faint to track motion. When the far lines rotated, they mapped disks in miniature. When they broadened asymmetrically, they shouted of winds. When they doubled, they announced clumps in orbit around a still-forming center. The synergy reduced fantasies to possibilities and possibilities to measurements. He formalized the ritual of certainty. Every candidate chosen by color moved through a filter of quality flags. Photometry was recalibrated for the small but lethal effects of nebular lines hiding in broad bands. Size measurements were corrected for the spread of the point function and for the loss of faint wings to the tyranny of surface brightness dimming. Detections were tested by inserting fake galaxies into real backgrounds and ensuring that pipelines recovered what they should recover and rejected what they should reject. The ritual took time. Time reduced regret. He learned to count without fooling himself. Completeness curves described the fraction of sources lost to noise at each magnitude and size. Contamination estimates described the fraction of interlopers that wore convincing colors by accident. These two functions entered every luminosity function and every mass function, like silent coefficients. Their inclusion turned surprise into a controlled deviation. Without them, wonder could be counterfeit. With them, wonder could be priced in units of sigma rather than adjectives. He refined redshifts with spectra that did not always chase the brightest. A quiet target that anchored an important part of parameter space sometimes mattered more than a dramatic showpiece. With integral field units, he moved beyond one line of sight to a postage stamp where each spaxel recorded its own spectrum. Velocity gradients revealed rotation or chaos. Ionization maps revealed compact engines or stellar neighborhoods with different temperatures and densities. In the small cubes, structure appeared that images had smoothed into a single glow. The cubes taught that even distant smudges have interior lives. He staged coordinated campaigns that visited the same sky with different tools and at different epochs. A deep image built the list. A slitless pass revealed the obvious lines. A shuttered exposure cleaned the contamination and secured precise distances. A cold dish traced the cool gas. The targets chosen this way fed back into the image analysis, tightening the priors on color fits and shrinking the confidence intervals on masses and ages. The loop was practical rather than poetic. It turned scattered clues into a file where each entry could be trusted to pull its weight in a statistical argument. He paid attention to the instrument's heartbeat. Persistence in detectors left after images that could masquerade as galaxies. Cosmic rays drew bright punctuation where there should have been silence. Flat fields shifted as the observatory cooled and warmed by tiny amounts. Calibrations evolved as more data arrived, and every evolution demanded that old results be reprocessed to keep faith with the present. The discipline of rerunning pipelines honored the truth that instruments learn their own natures over time and that measurements grow more honest as that knowledge matures. He engaged the public sky as well as the private archive. Quick release images were not scientific proofs, but they were invitations. Citizen eyes found arcs missed by algorithms. Amateurs noticed mirror ghosts that resembled sources. Discussion sharpened the next iteration of masks and catalogues. The culture around the data became part of the toolkit, a distributed quality control that operated at human speed, even as analysis ran at machine speed. Transparency about methods kept this collaboration honest, and honesty kept the collaboration productive. He prepared for the edge cases that define the art. A candidate at the very limit of signal screamed for corroboration in a different band or at a different angle. A compact point with extraordinary color whispered of a small accreting engine rather than a star-forming knot. A patch of diffuse light around a bright arc could be intracluster glow or a lensed host. Each ambiguity had a diagnostic sequence: rotate, reobserve, change the role, shift the filter, ask the shutter to open on the question. The sequence did not promise resolution every time. It promised that doubt would be reduced methodically. He ended by arranging the orchestra for what comes next. Maps deeper by a factor of a few will push well past the knee of the luminosity function. Wider mosaics will tame variance and reveal whether bright fields were lucky alignments or fair samples. Spectroscopy will move from dozens to hundreds of confirmed elders in a single program, enough to build distributions rather than lists. Cold dishes will add velocity maps to light maps, converting shapes into dynamics. Each listener will keep to its register while leaning into the others, an ensemble that hears the dawn, not as a rumor but as a score that can be performed again, checked, and refined. In that rehearsal and reperformance, the first morning will cease to be a picture. It will become a measured event. He laid out a table of trials. Not prophecies, but measurements designed like locks and keys. Each test would either open a door or rattle it hard enough to force a new carpenter's hand. He did not stack them as curiosities. He arranged them as a crossfire, axes of inquiry set at clean angles, so that error could not hide where two beams overlapped. He began with counting that refused to remain a simple census. The brightness distribution of the earliest galaxies is a curve with a faint end and a bright shoulder. Deep images push toward the faint end until the sky itself sets a floor. Wide images cover enough area to catch the rare brights without mistaking fortune for truth. Plot the number of sources against luminosity, and the slope will reveal whether small halos were abundant or trimmed, whether warm motions in the dark erased seeds or left them intact. A turnover too early would favor a universe that smoothed its smallest wrinkles. A steep rise would argue for crowded nurseries that fed reionization by sheer arithmetic. The curve will not flatter guesses. It will write them in numbers that future eyes can check without sentiment. He prepared a ledger of lines rather than light alone. Oxygen, hydrogen, and neon speak in measured ratios that diagnose temperature, density, and metal content. Measure O3 against H-beta across a population, and the distribution of equivalent widths will test whether stellar populations were unusually hard and whether gas pressures soared. Assemble the balance between C2 and the far infrared glow over many masses, and the result will say whether dust hid more star formation than colors admit. Tie those lines to precise distances, and a three-dimensional map of ionizing budgets emerges, a budget that must be high enough to lift the cosmic fog without violating the quiet of the background radiation fields. Equations here are not indulgence, they are audits. He arranged a meeting between maps that hear different registers. Galaxies mark where light was made. The long wavelength signal from neutral hydrogen marks where light had not yet won. Cross-correlate their positions. If galaxies sit inside cavities in the neutral map, the correlation will flip sign on the scale of the bubbles. The scale will migrate with time, shrinking at earlier dates and widening as cavities merge. The pattern will discriminate between scenarios where many small sources nibbled the fog and ones where fewer large sources carved it faster. A universe can lie in either map alone. It struggles to keep a straight face when two maps argue in public. He insisted on timing rather than only geometry. The damping wing of Lyman alpha carries the memory of neutral gas along a line of sight. Fit its curve in a small set of carefully chosen galaxies whose continuum is known, and the amplitude of neutrality along those paths appears. Collect dozens of such curves at slightly different ages, and the timeline of clearing emerges without leaning on global averages. Add the sizes of proximity zones around bright beacons, and the temporal shape sharpens further. A quick rise followed by a brisk coalescence would codify the feeling of a decisive dawn. A languid drawl would force cooler interpretations of early vigor. He prepared diagnostics for the most fragile signatures of the first stars. A helium line in the ultraviolet at a rest wavelength that implies severe patience from instruments will, if found strong and narrow without the companions that nuclei prefer, advertise very hot, metal-poor clusters. Pair this with the absence of mid-infrared molecular bands, and the case strengthens for a top-heavy population that briefly ruled. Measure the rate of the rarest supernovae, the ones whose light curves betray pair instability in extremely massive progenitors, and the chemistry of the first factories finds an event to blame for its speed. Failures count too. A quiet ledger of such explosions would tighten the leash on speculative mass functions. He required dynamics, not just portraits. Far infrared lines that rotate sketch miniature disks or tangled inflows. Stack velocity maps for samples grouped by mass and age. If ordered motion dominates, then internal reorganization by clump migration can build compact cores on its own schedule. If chaos rules, then mergers get the credit. The widths of lines, the tilt of gradients, and the asymmetry of profiles do not shout for any single object. They sing a choral truth when averaged over many, a truth about how mass rearranged itself on timescales that images cannot display. He called for patience with engines at centers. X-ray stacks of faint sources that show mid-infrared heat and hard lines will test whether hidden nuclei lurk behind dust. An excess of hard photons, even subdued by absorption, would argue for more common black holes than current limits admit. Absence would push growth into quieter channels. Variability at the threshold of detectability, measured across revisits, will place upper limits on the sizes of emission regions and, by implication, on feeding rates. Small flickers are not gossip. They are geometry measured in hours. He set out tests that use gravity as a lens and as a rumor. Strong lenses split background galaxies into multiple images. Differences in their brightnesses, once lenses are modeled, betray small-scale structures along the path that either exist or do not, depending on the warmth of dark matter. If subhalos are missing, flux ratios will settle into smoother patterns. If subhalos abound, the pattern will break symmetry. In the same frames, microlensing across lensed arcs can probe for compact intruders, such as primordial black holes in narrow mass windows. A strange twinkle against a stretched galaxy is more than pretty. It is a verdict on ideas that reach back to the first instant. He added a class of listening that does not use light. Space will soon tune an ear to low-frequency gravitational waves. If the earliest heavy black holes grew by frequent mergers inside dense young galaxies, a ground note made of many overlapping events will rise from the background. If instead seeds were born heavy and fed steadily, the note will be quieter and the soloists rarer. Map that spectrum and a genealogy unfolds, a cross-check on assembly histories derived from spectra and images. The early universe will then be heard in two languages that do not mistranslate one another. He wrote a small but sharp paragraph about local fossils. Stars in nearby dwarf galaxies and in the halo of our own carry chemical patterns that read like birth certificates. A generation enriched by the first explosions leaves telltale ratios of carbon, magnesium, calcium, and iron. Count the most pristine survivors and their abundance patterns. Compare these counts to yields required by distant line budgets. Agreement would confirm that the furious youth implied by red smudges left descendants in the neighborhood. Disagreement would push the timeline of enrichment toward or away from certain masses and explosion types. Archaeology becomes a test of headlines written in far infrared. He demanded a disciplined hunt for leakage. Direct detection of ionizing photons at the same epochs is beyond present reach, but at slightly later times analogues exist. Choose galaxies with line ratios and morphologies that resemble early factories. Measure their escape fractions with deep ultraviolet imaging and spectra. Correlate the fractions with indicators of porosity and pressure. Then carry the calibrated relation backward in models and ask whether the early population, given their measured structures, could have lifted the fog. This is not a proof by analogy. It is a bridge built with measured planks that will hold or crack depending on the load. He acknowledged the tyranny of systematics and made them part of the plan. Photometry will be rerun with evolving flats. Size measurements will account for wings too faint to see in individual objects by stacking profiles. Spectra will be corrected for scattered light and for persistence that leaves false echoes. Simulations will project stars on detector planes and recover them with the same pipelines that process the sky, a rehearsal designed to catch biases that prefer wonder over accuracy. The discipline will not add romance to the story. It will add confidence, which is better. He argued for timing, cadence, and repeatability. A field imaged once can deceive. A field imaged twice, at two orientations with two instruments, and with a third map of the same sky in a different band becomes an anchor. The schedule of visits will be written with science rather than convenience in mind. Some targets will need a winter and a summer to reveal whether their hearts flicker. Some will need a lens refined by a foreground spectrum taken when a bright galaxy passes the slit. Coordination will replace serendipity without banishing it. He ended with a contract that measurements make with theory. If counts flatten where smooth dark matter would not allow, if line budgets exceed what safe star formation can supply, if cross-correlations between galaxies and neutral maps trace bubbles larger than patience alone predicts, then the dials on the familiar equations must move. If instead the curves bend within reach of efficient but orthodox recipes, then the surprise will mature into an adjustment rather than a revolution. Both outcomes are successes. Each brings the first morning into sharper focus. The tests are already written. They ask the sky questions that cannot be answered with taste or temperament. They invite the universe to confirm whether its earliest work was merely quick or also truly strange. He treated light as speech, and the sky as a page, where meaning arrived slow. A single image was a letter, a spectrum was a syllable. A collection of spectra made a word. Across fields and seasons, words joined until sentences formed that no longer depended on metaphor. The grammar of the first morning emerged as relations, each with subject, verb, and object. Gas collapses, stars ignite, photons escape. The verbs never sat still. They conjugated in redshift and number density, in line ratios and velocity width, until a language took shape that translated distance into history without losing poetry. He began compiling an alphabet. Breaks were consonants, crisp edges that stop breath and mark boundaries. Lines were vowels, carriers of tone and color that give feeling to structure. Between them lived modifiers and diacritics. Equivalent width altered emphasis. Slope colored attitude. Width added the sound of turbulence or the hush of order. Sometimes the page held a marginal note in dust, a faint tint that changed a meaning without erasing it. He learned to read with both patience and suspicion. Letters can look alike in the dark. He demanded that the same word be legible by more than one script, imaging and spectra, light and radio, depth and breadth. He drew a primer in rules. The first rule said that brightness grows from a compromise between gravity and feedback. The second said that metals appear as soon as stars die, and once metals appear, cooling changes its accent. The third said that light does not leave at random, but finds exits cut by winds and pressure. The fourth said that mass gathers according to a choreography written long ago in a low roar of fluctuations. Each rule possessed exceptions that were not excuses but dialects. Overdense regions spoke faster. Isolated pockets spoke slower. Lenses amplified the quiet and sometimes introduced stutter. He kept a ledger of dialects, so local accents would not be mistaken for new grammar. He taught himself to parse clauses nested inside larger statements. A compact core with warm dust and hard lines could be a subordinate clause that modifies a main statement about star formation. A broad, gentle halo around the same core might act as an adverb, softening the pace. Velocity gradients became commas, small pauses that turn a string of descriptors into ordered thought. Absorption troughs were ellipses, hints of material intervening, a note that someone else was speaking in the same breath. Silence itself served as punctuation. Missing lines carried almost as much force as present ones, telling of neutral regions and concealed engines, of distances that mute certain syllables until the fog lifts. He mapped syntax at larger scales, clustering arranged nouns into phrases that recurred. Groups and filaments behaved like grammar constructions that reappear across a narrative. Their presence made new meanings possible. Overlap between ionized cavities became a conjunction, joining separate lights into shared clarity. In those joins, the language sped up. Sentences shortened. Communication improved. The foil to this clarity was recombination, a contrary conjunction that tried to slow and complicate meaning by restoring opacity. He took comfort in the rhythm. Even early, the text did not ramble. It paced itself in patterns that statistics could confirm. He distinguished between semantics and pragmatics. A model carried semantics, a mapping from words to worlds. It said that a given pattern of lines meant a certain temperature, density, and metallicity. It said that a slope implied a dust law and a history of starbirth. Pragmatics asked whether those meanings worked in practice across fields, instruments, and times. An explanation that fit one spectrum but failed in a stack of many had poor pragmatics. An explanation that predicted a map of neutral patches that cross-correlated with galaxies had better pragmatics. The language of the dawn rewarded theories that could be spoken in many scenes without losing sense. He built a dictionary of metaphors that became measurable. Fire turned into star formation rate. Smoke turned into dust mass. Haste turned into specific star formation rate. Crowd turned into number density. Confidence turned into compactness and surface brightness. Appetite turned into accretion rate. Each entry gained a precise unit, and each unit admitted an error bar. Error bars were not apologies. They were parentheses, structures that hold nuance close without pushing it into the center of the sentence. When parentheses shrank, prose tightened. He felt no shame in celebrating punctuation. He tested the language for self-consistency. If a population looked old by its continuum shape, the same population had to carry the required metals in its gas. If metals were present, dust ought to hum somewhere at long wavelengths unless geometry hid it thoroughly. If dust hummed, ultraviolet slopes ought to tilt accordingly unless a top-heavy chorus sang loudly enough to mask the tint. If a top-heavy chorus sang, line ratios and ionizing budgets had to keep time. The checks knit separate sentences into a paragraph that could withstand skepticism. Skepticism in this craft was not a sneer. It was a red pen that improved style. He listened for poetry within limits. A helium line unburied from noise read like a half line from an epic, sung once and remembered. A stacked detection of faint carbon in cool gas read like a chorus, the meaning found in repetition rather than volume. A slight shift in the damping wing read like a change in mood halfway through a stanza. The point was not to decorate with imagery. It was to acknowledge that language and measurement share a discipline. Both require structure. Both thrive when detail serves a larger arc. Both fail when flourish replaces argument. He taught machines to read with him. Algorithms learned to recognize the characters of arcs and dots, to tell a lens from a spiral arm, to separate a real smudge from a cosmic ray. Neural networks became quick students of fonts and ligatures that instruments imprint on data. He did not surrender meaning to them. He asked them to copy with speed and consistency while he kept the right to edit. When a network flagged an extreme candidate, the next step was still human grammar. Assemble spectra, verify distances, cross-check with lines. The collaboration felt like co-authorship, where one mind drafts and another revises. He placed the new language beside old tongues. The background radiation spoke archaic, a clean script left from an age when everything was hot and simple. The web of galaxies spoke classical, a prose of structure stretched over billions of years. The first morning spoke lyric. It moved quickly, it kept rhythm, it surprised with density, and it returned to themes with variations that mattered. Keeping these languages in conversation became the art. A phrase in one could not contradict syntax in another without consequence. He favored translations that preserved sense rather than meter, and he favored tests that would expose mistranslations early. He minded the ethics of interpretation. Data are not props for a story already chosen. They are utterances that deserve the courtesy of being heard before any plot is assigned. Courtesy took the form of blind analyses, of pre-registered cuts, of pipelines that did not peak at results before deciding thresholds. Courtesy took the form of releasing code and masks so that strangers could check the grammar. He discovered that humility improved fluency. The more he admitted uncertainty, the more rapidly certainty accumulated where it could. He listened for the accent of time. Words meant one thing at one redshift, and another slightly different thing 200 million years earlier. Duty cycles shortened or lengthened. Escape fractions rose or fell. Pressures thickened. Metallicities climbed. The same phrase, Lyman alpha emitter, could describe a speaker with a different social context depending on how numerous neutral neighbors remained. He kept a concordance that recorded these shifts. Without it, conversation across epochs risked confusion. With it, meaning tracked change without pretending to permanence where none existed. He allowed himself a final grammatical observation. Beginnings in this language are not nouns, they are verbs that never cease. To begin is to organize, to cool, to ignite, to sculpt, to expel, to admit, to learn. The first morning did not happen and then end. It happened and continued in every structure that still forms, every outflow that still carves a channel, every photon that still flees along the axis of least resistance. The telescope did not merely witness vocabulary. It entered a seminar where the universe rehearsed the conjugations of to become. He wrote the lesson as carefully as his instruments allowed, aware that every correction and every new test would change a clause here or a tense there, yet leave the central sentence intact. The cosmos spoke. The syntax was swift. The meaning was patience made visible. He stood at the boundary where instruments fall silent, and imagination keeps a respectful watch. The light had spoken in careful measures. It had revealed a morning rich with compact cities of stars, with soot from the first fires, with lines that rang at pitches both familiar and newly bold. Yet beyond the furthest confirmed distance, the curve of possibility remained. The page continued into margins inked by noise and patience. He understood that this border was not a failure of technology alone, it was a property of beginnings. The earliest moments prefer to veil themselves in expansion and scatter their truths across wavelengths that stretch beyond easy reach. He learned to accept that clarity sometimes arrives sideways. A distant spectrum pins a date. A map of cold gas sketches motion. A quiet X-ray stack hints at hidden engines. None of these single notes resolves the chord. Together they make a harmony that invites a deeper listening. At the edge, the discipline is to refrain from decorating gaps with certainty. He chose instead to let surprise remain honest. When a galaxy looked older than its age permits, he did not declare a revolution. He asked what slight revisions to cooling, starbirth, and escape might produce that look without breaking what already works elsewhere. When the revisions held, he kept them. When they broke another cherished fit, he set them gently aside and looked again. He found that humility is an instrument as precise as any mirror. It keeps focus on the sky rather than on the interpreter. It allows correction without shame. It honors the provisional nature of knowledge, especially at an hour when the universe speaks in a dialect learned only yesterday. He practiced this humility by returning to fields already celebrated and treating them as if new. The same arcs revealed subtler structure when models improved. The same candidates, once noisy, stood firm or fell away under deeper exposure. The frontier moved not only with fresh territory, but with improved hearing in familiar rooms. He felt a tenderness toward error. Early claims that grew quiet under scrutiny did not embarrass the craft. They taught the craft where temptation hides. Temptation thrives in elegant plots, in colors that suggest a story so compelling the mind forgets to test. Error places a hand on that shoulder and says, "Remember to measure." In this way, the edge becomes a teacher of character, as much as a frontier of knowledge. The light is old, the minds are young. The conversation between them matures only when eagerness is balanced by discipline. He recognized that the edge is populated by futures. Space-based ears will hear gravity's bass and tell whether heavy hearts collided often in the first dawn. Arrays on high plateaus will paint neutral hydrogen like weather radar and show bubbles growing into each other until a clear day emerges. Telescopes on mountains will push deep into the red, resolving lines too faint for the current eye. Algorithms will learn to refuse illusions more quickly. Pipelines will fold in the lessons of persistence, scattered light, and false positives until cleaner catalogues become ordinary. None of these futures changes the old fact that light takes time to arrive. All of them change how much meaning can be extracted from the light that does. He let himself consider an idea that is not mystical, but still feels intimate. The reason the first morning matters is not only that it is first, it is that it contains the rules by which evenings are still made. Every cluster today inherits the haste and discipline written then. Every quiet disk around a calm nucleus carries the memory of early turbulence tempered by feedback. The chemistry in a leaf or a bone owes its abundance pattern to furnaces that burned while the fog was thick. To study that hour is to learn the grammar of becoming, the syntax by which matter learned to tell itself into complexity. He refused the romance of a neat ending. There is no curtain call for the dawn. The universe did not move from a chapter called beginning to a chapter called now with a clean page break. The verbs that defined the first morning continue in every merger and in every small galaxy that still tastes the background warmth more strongly than its cousins. The telescope taught this lesson by turning the distant into the legible. The intimacy that results is not an illusion. It is a rightful relationship with history. He learned to use this relationship without making himself its center. He returned often to the sensation of scale. A pinprick on a detector summarized millions of suns, each a furnace, each pouring out photons that crossed a space expanding under them. That pinprick entered a file on a server. It became a table row, a plot point, a sentence in a paper, a frame in a film. Somewhere, this translation acquires a moral dimension. To handle those pinpricks with care is to respect the labor of gravity and time. To treat them as trophies is to cheapen both the cosmos and the craft. The edge sharpened this feeling, because the rarer the data, the more easily pride masquerades as truth. He noticed that the darkness itself had changed character. Before the measurements, darkness was a lack that invited projection. After the measurements, darkness became a surface where faint structures pressed outward, asking to be resolved. He saw filaments implied by clustering statistics. He saw bubbles implied by line profiles. He saw a web in negative that future radio maps will draw directly. The edge was not emptiness. It was a lace of almosts and not yet, an embroidery whose pattern could be predicted in outline and awaited in detail. He cultivated patience as a form of courage. The courage did not lie in bold declarations. It lay in staying with a field long after novelty fades, in reprocessing data when calibrations improve, in teaching a community to value confirmation as highly as discovery. He learned to celebrate the paper that says this bright candidate was misled by an emission line with the same sincerity as the paper that anchors a record redshift. Both serve the truth. Both bring the frontier into focus. Both are acts of respect for light that has traveled longer than any sentence the mind can compose. He came to prefer questions that lengthen awareness over answers that shorten it. What is the distribution of escape fractions as a function of compactness and pressure? How frequently do small engines hide in bright factories? Where does neutrality linger longest and why? How does duty cycle shape the memory of a population? Each question implies methods, instruments, and collaborations. Each binds observers and modelers into a single craft that learns by arguing gently. In this preference, the edge becomes a common room rather than a wall, a place where different expertise sets share a table and pass the bread of skepticism and the wine of wonder. He allowed the telescope itself to be a character in this reflection, not as a hero, but as a patient witness. Its mirrors take no sides. Its detectors prefer no interpretation. It pays attention without fatigue. This steadiness is not human, and that is part of its virtue. It grants to the mind an example of devotion to clarity. It also grants to the mind a reminder that clarity requires shelter. The sun shield, the cold, the quiet station in space, the choreography of small movements that hold a star steady for long hours, all of this is the architecture without which attention collapses. He learned that curiosity is not a feeling alone. It is an engineering project. He concluded nothing absolute. Instead, he let a sentence settle that could survive better data. The first morning was bright with structure sooner than many expected. Its factories worked efficiently in gas-rich rooms. Its engines began to hum, while the fog still clung to the hills. Dust appeared early enough to help and hinder at the same time. The fog lifted decisively rather than slowly. Simulations learned to reproduce these facts by adjusting rhythms rather than replacing laws. Future ears and eyes will draw the bubbles directly and hear the mergers sing. In that chorus, the edge of our knowing will move, and the movement itself will be the story. He stood at the boundary, and did not ask the universe to resolve into certainty. He asked it to keep speaking. He promised to keep listening with instruments and with restraint. He promised to let wonder be disciplined, and to let discipline remain tender. He promised to treat every new red dot not as a conquest but as a guest. At such an edge, hospitality to truth becomes the last and best method. The cosmos accepts the invitation by arriving as it is, not as the mind prefers. That arrival, seen in quiet images and sparse lines, is enough. He slept with the window open to a night that had no air. In the silence, light from a time before verbs gathered on a mirror far from weather and folded itself into numbers. Those numbers drifted down wires to rooms where patient screens flickered. In each pixel, a city of stars breathed, small and impossible, and yet there, like a lantern glimpsed through fog on a river no map admits. He dreamed not of answers, but of distances turned into music, of lines that rise and fall like a chest pulling air, of dark threaded by silver where filaments tie the sky to itself. Morning, the ordinary kind, pressed pale light against the glass. He woke with a simple thought that felt like a vow. To ask is not to command, to measure is not to possess. The universe teaches by remaining enormous, by keeping beginnings just ahead of the hand that reaches. What the telescope saw was not a secret uncovered, but a greeting accepted. It was the sound of first fires carried across expanses that turned speech into whisper, and whisper into faith. It was the discovery that time can be read if one is willing to read slowly. He closed his eyes once more and offered gratitude to gold petals that do not wilt, to engineers who teach metal to hold still, to spectra that write in tiny slanted script, to dust that both hides and reveals. He felt that gratitude widen until it reached things without names, the rhythm of expansion, the patience of gravity, the courtesy of atoms finding each other in the dark. He let the feeling pass through him like a tide, not to keep, but to remember. When he rose, the dawn outside was young. Somewhere, the dawn he studied continued without end. Both invited the same posture. Look closely, speak carefully, hold wonder and proof in both hands. And listen, always listen, for the faint red syllables of a beginning that has never stopped beginning.